All right, so we should be up and running. I got the telescope outside, and today I'm using a same as I was using the other days. It's a 8-inch f4 Newtonian and a ASI294 camera, and it's all being controlled by this little mini PC on the mount. And right now I'm remote desktoped into that little computer using my indoor desktop, so I have full control and I get to see the displays. So it's just like I'm out there, but I get to be inside in comfort and live stream. So I do short exposure live stacking, mostly for sort of as an observational tool. What's called electronically assisted astronomy. Goes by a bunch of names, but that's what they call it on cloudy nights. So it's kind of fun using short exposures to just see stuff, not so much to get the best picture or the best end result. So over here, this is SharpCap doing the live camera feed right from the camera. Has basic controls for exposure length, can increase or decrease, and there goes a satellite right there. You can also apply a histogram stretch to the displayed frames just to accentuate any faint fuzzy things. And you can also do live stacking, which we'll get to later. And over here I have Carte de Ciel, which is my planetarium, and this is like a digital sky map, and it's showing where my telescope is pointing relative to the sky. So right now we're pointing at Vega and Lyra, and I also have a wide field camera. Let's see. And this is showing, if we go to here, this very large rectangle represents the field of view of the wide field, and it's pretty large, so we can see the entire constellation of Lyra, and we can see a tree, because I've got pretty bad horizons all the way around. Let me just position this. Alright, so very close stop, not too far from where we are, is the Ring Nebula. It's a really nice planetary nebula right in Lyra. So we'll go there. It's usually this time of year I usually end up finishing my star alignment on Vega. So this is usually a good first check to make sure everything's working. Hi, Gary. So right now we're just looking at the raw 2-second or 4-second frames coming from the camera. I could even go down to 2-second or 1 second. So the shorter the exposure, the fainter everything is, but the more real time it is, which is kind of nice. So it looks pretty dark, but when you apply the histogram stretch on this little display histogram, you can pull out some good detail. And the challenge for tonight is I'm actually under some sort of moderate smoke from the western fires, even all the way out here in Massachusetts. So the camera's still putting up a good fight, pulling out pretty good detail. So right now we're on very short 1-second exposures, sort of aggressively boosted or stretched, and you can see there's tons and tons of noise. But as we increase the exposure, say to 2 seconds, the noise should start to decrease. Now we can go all the way up to 8 seconds, and the longer we expose, the less noise we'll have. But the really cool stuff is live stacking, and with that you can accumulate frames over time, and that is essentially like an effective really long exposure. And when you do those, the noise really plummets and smooths out, and you can get a lot of detail. So I'm at 8 seconds, and I can apply a dark frame to match. So actually we'll demonstrate, if I turn the dark frame off, we'll see what they're used for. So let's see. So without the dark frame, we should see some hot pixels, although the camera's cooled, so it's pretty good about that. I'm not seeing them, but in a live stack they'd probably show up. There's a red one down there. But the dark frames also help correct for any amplifier glow on the sensor. So they're really, really helpful. So I always use them. And you just have to match for every combination of gain and exposure length and camera temperature, you need to have a matching dark frame. So I've got a little library that I pull from. So here we are with dark frames, flat frames, and well, I should get to a flat frame corrects for any vignetting. If you've ever seen like old photography where the outside border is dark, a lot of telescopes do the same thing. So you can essentially take a picture of a flatly illuminated panel, and that'll show any of that vignetting, and you can use that to counteract the vignetting. So I've got dark frames, flat frames applied. We're at 8 seconds, and can start a live stack. So this will start to accumulate all these little 8-second exposures, and as we do that, that noise that we saw earlier should really, really start to dissipate pretty quickly. And the longer you look at something, the longer you stack it, the smoother and smoother it gets, and you can kind of boost it even more. So down here is the histogram for the live stack, and this represents all the data that the camera sensor is picking up. This is sort of a plot of how many pixels have what value. So all the way down here is 0 value, completely black. You can see right now there's no pixels that are completely black. But as you go to sort of very, very dark gray, we start to see we've got a lot of kind of dark gray pixels. And then sort of halfway would be 50% gray. All the way over here would be completely white, overblown. So we don't have anything that's overblown. So most of our data is kind of right here. And that kind of just results in a kind of bland, low contrast, kind of gray picture. But the really nice and powerful thing with the histogram is you can remap how that small amount of data is displayed. So you can take the black point and bring it all the way over here, and that'll essentially clip out most of the sky. And now the object that we're looking at is not much brighter than the sky. You know, it's barely kind of dark gray. So another powerful tool is this midpoint, or the 50% gray. We can slide that over here, and that'll increase the difference. It'll, you know, brighten those very dark grays and make them much more noticeable. But you also start to lose I don't have my alignment turned on, so my mount is not very good. You know, if I were to try to take, this has only been 2 minutes and 16 seconds, so if I were to do conventional photography unguided, this is what my sub exposure would look like. It'd be smeared and I'd lose all my detail. So I'm going to turn on align frames here, and we'll clear this out and restart. And what this is going to do is the first picture that comes in, it's going to analyze it, find all the stars, and then when the second picture comes in, it'll analyze that picture, find those same stars, and it'll automatically align the two pictures, and then it averages it. So by doing that, every new frame is perfectly aligned, and you get to have a nice sharp picture as you watch something for a long time. And that lets me use a very inexpensive, cheap mount. So in traditional astrophotography, it's usually the mount is crazy expensive because people are trying to take, you know, multiple minutes long exposures, which can be very challenging. But the end results are fantastic. This is just an easier way to sort of do it. The end result's not as great, but I use it as an observational tool, and compared to visual in an eyepiece, it's an incredible improvement. It's not quite the same experience, but for for just raw power to be able to see these things, and especially to see these things in color. The live stacking is fantastic. So I had boosted, sort of had it stretched a little too much there, and all the colors were kind of bleached out because it was so bright. Gary's asking about the image settings over here. I think by default the ZWO camera was using 8. I left it where it is. I never really messed with that. And the white balance was set at 50-50. And I just experimentally one night had it pointing at the sky, and I adjusted the white balance to get it closer to balanced. I think at the default setting the sky was extremely green. So this is sort of a rough pass, but generally I do most of my color balancing down here in the live stack. There's sliders, and that lets you adjust things. And there's an automatic button, so usually I'll click that and that'll get close. And then by eye I'll look at it and think maybe that's a little red, so I'll decrease it a little bit. And when you click, instead of clicking and dragging the slider, which can be kind of tricky, you can just click above it or below it, and that'll just shift it down by 1 increment. And the same works for all of these sliders. So when I change exposures, I don't actually slide the slider, because if I were to click and drag this, you see how the decimal point changes. It's not sort of, doesn't click into uniform increments. So I've got it back at 8 seconds. What I do is I just click to the left, and that'll cut the exposure in half, in half, in half. Or click on the right side, it'll double it, double it, double it. So by messing with those exposures, I've probably, I've messed with the histogram, because for a couple frames it took on some shorter, dimmer ones. So this histogram's gonna kind of wiggle around a little bit. So I'm gonna name this as M57, and this gets appended to the file name just so you can keep track of what you're looking at. I'm gonna clear the live stack just because I was messing with those exposures. It'll make it harder to stretch because it won't be as stable. It'll tend to drift around. But if we actually look at this, this is we should be able to get some nice detail. So far, this bodes well for tonight. I wasn't sure if the smoke would cut too much light or not, but it seems to be working well. And we've only got 3 frames, and we can already start to see some slight modeling texture in the red areas are primarily hydrogen alpha, and I think the blue-green area is oxygen 3. But this is pretty close to the resolution limit of my setup. If I keep zooming in, you'll start to see individual pixels. But you can definitely see little kind of clumps and knots of hydrogen alpha out there, which is pretty cool. Gary's saying he's having some trouble with the brightness control. I'm not too sure about when to adjust it and when not to. I've just kind of left it alone. I know that I think when you change this, you also, your flat frames, if you're taking bias with flat frame, so in SharpCap there's a tools to help you capture flat frames and dark frames. And in the flat frame tool, there's a tick box for also capturing bias. And I know when you use that, it's critical that you do not change any of these settings from the time that you take your flat to the time that you take your exposures. So a mismatch of that might wreak havoc. I'm not sure though. I haven't really played with it much. And it looks like up here, just barely start to make out a little gray smudge. And that's a very distant background galaxy. So the ring is looking pretty good right now, but that little galaxy is kind of hard to see. So we can sacrifice the ring nebula in a way to try and accentuate that little galaxy, and just kind of using the camera as an observational tool, not necessarily concerned with beauty. But we can definitely tell something's there. So I think I'll save here. And tonight I'd really like to get a look at the fireworks galaxy, which I think is just crossing the meridian now. I forget the number. Let's see. It's in Cepheus. Should be there. Yeah, 6946. So I can tell the telescope to go there, and we can check the wide field camera, and this will show us if we're going to run into any trees, although I'm pretty sure it's clear. And I really like having this wide field sort of e-finder. Helps reconnect to the scope because it's outside and I have no clue what it's looking at. It could, you know, cloud over and I'd have no idea. So this is useful for kind of keeping tabs on that. And another thing I recently did is in Cartesiel you can map out your horizon and it'll plot it on the sky chart, which is nice. So I've got put it into all sky mode. This ring represents a perfect horizon if we're in the middle of the ocean, and you can see how much of the horizon I'm missing. So if we, right now the camera should be pointing at the fireworks galaxy, but because we're running a live stack, you know, the view didn't update because it's still trying to stack the ring, and it's right now it's confused. You can see down here it's saying frames ignored because it's no longer receiving the pictures it's looking for, so it can't stack them. The stars don't match, so it's kind of complaining. So I'll exit the live stack. We'll zoom out and just see if we're on target. So it looks like it's right there, a little right of center, and we can stretch the individual frames down here in the display stretch. And what I like to do for positioning is I'll just decrease the exposure down to 2 seconds and then apply a stretch just so we can see, I mean, we don't have to see the full detail of it, but just to know that it's there. And now I'll take the hand pad and I'll take a guess whether it's east or west. Looks like I made the right guess. So I can stop the mount. It should be close enough. It doesn't have to be perfect. There's plenty of real estate to work with. So now that we're centered and on target, I'll increase back to 8 seconds. And I will note the name, NGC 6846. I forget the name. I'm terrible. I'm so bad with the numbers. Let's see. 6946. Close. And the common name is Fireworks Galaxy. So I'm going to stop stretching the frames just because we don't need it. A lot of times I'll forget to sort of reset that stretch, that boost, and I'll end up doubly boosting it and it gets crazy fast. A lot of times I'll be sitting here trying to adjust this histogram, wondering why it's not working or why it looks so bad, and then I'll realize that it's also stretched over here, which, you know, it's like double multiplication. It really messes it up. Hey Vina, how's it going? So it looks like we're on target for this one. We've got 5 frames, about 40 seconds, just using short 8-second exposures at medium high gain. Sort of anywhere between 2/3 and 100% is usually pretty good. And this one I think I'm going to let run for a while. I'm curious to see how well we can resolve this one. And now eventually I'll have to dither a little bit. So even with all of these calibrations, there's still a little non-uniformity with the sensitivity of the camera, and it ends up having like a little splotchy texture that gets baked in. And if we continue to live stack in the exact same position, that because that texture is sort of fixed with the sensor, it ends up kind of getting baked into the picture. But if we pause the live stack and nudge the telescope a little and then resume, relative to the stars, now that pattern is relocated, it's different. So on average, it should start to average out as long as we sort of relocate it every now and then, and that's called dithering. And normal astrophotography, they've got methods of automating it, and it all happens automatically. But for me, it's simpler for me to just do it manually, pause, nudge, resume. I only do it a couple times, and only for sort of critical items. A lot of things that are high contrast, it doesn't really need it, but this galaxy is pretty faint, or it's very large and diffuse and has a very feathered edge. And tonight this transparency is absolutely terrible because we've got smoke coming over. So this one should be pretty challenging. But it's a beautiful galaxy. Tons of little nebula and star forming regions. I always think it's so cool to be able to see that in another galaxy. You know, I'm not sure if it'll have the distance. Usually, that's one thing Cartesio lacks, is good information on the objects. But Sky Safari is way better, or Stellarium is better. It has a lot of info on there. So I'm going to pull up some info on this one. We'll just let it live stack and improve. Yeah, I think actually I'll do a little manual dither now. So I've paused the live stack and I've chosen to view the raw individual frames that are coming in instead of the stack. And now I can go to my scope control and I'll just nudge it north for maybe 1.5 seconds and pause. And hopefully that'll be enough just to shift it. Maybe, you know, that's more than enough. So that should be fine. Once the mount settles down and stops shaking around, then I can resume the stack and switch over to start viewing the live stack again. Maybe you can see that slight modeling I was talking about, where this little sort of darker and brighter patches, almost like film grain. But it should start to even out as we reposition the camera a couple times. And by doing that, we'll also sort of burn up some of our field of view, because now the camera's no longer looking at exactly the same area. So all the area here is no longer receiving data from the camera, so it's losing brightness, because essentially every time a new frame gets added on, this whole strip gets 0 value. So eventually that'll start to fade. And you'll see down in the histogram there's a second peak starting to form, and that's this area here as it gets darker and darker compared to the main image. but maybe we can stretch it a little farther. You can definitely see there's a pretty large nebula there, or star forming region. Don't know. It doesn't look like it. Doesn't look like that small patch is cataloged. So it would be right there. So I think I'm going to nudge the mount again. So we'll pause, look at the individual frame, bring up the scope control, and this time I'll go west for just a second. That's all it takes. You only need to move maybe 30 pixels. That last one was a little excessive. But we'll just wait for it all to settle down, and now we can resume the live stack and go back to watching the stack. And we can also check this drift graph down here, and this is showing us how much SharpCap has to move the pictures to get to line up. So you can see we started at kind of 0, 0 right here, and then we moved the mount vertically, and that was about maybe 125 pixels, and now we moved it horizontally. So you can see the different groups of locations that we are stacking. And this is one for rotation. So if we were on an alt-azimuth mount, this would show how much field rotation it's counteracting. You can see the values here, just teeny tiny, because it's auto scales. Because right now I'm on an equatorial mount, so it shouldn't rotate too much, but there is some flexure and deflection and stuff that might show up. Seems like SharpCap's accurate enough to pick that up and counteract for it too, which is nice. But you can definitely see the spiral arms, which is great. So Venu is asking about the catalogs in Carte to Seal, and the base installation of Carte to Seal doesn't have, it just has a very basic catalog. And on the website, on their download section, if you scroll down, there's a bunch of additional catalogs that you can install. So if we go here to catalog, I've got go to Deep Sky. I've got all these additional ones installed, and I think it's PCG LIDA, which is the really deep galaxy catalog. Like all these teeny tiny little ovals in the background. All of those are just absolutely tiny, super distant background galaxies. Another really cool thing is you can get the Gaia catalog. So let's see. Oh, here it is. So it's a big download. So there's an all-sky survey, the satellite that's taking photometry on just all the stars in the sky, and the really cool thing is they release their data publicly. So the Cartesial author packaged the Gaia data release in a way that it can be used in the star chart. So if I zoom way in, we can start to see the Gaia catalog. Actually, we might even start to see the galaxy if I turn off the picture and bump up the stars. You can already see the spiral stars, the spiral arms traced out by the faint white points, and that's all the Gaia data actually picking up stars in another galaxy, which is pretty crazy. It's almost overwhelming when you're looking at the Milky Way areas, just because there's like millions of stars get rendered. You can actually just see dark nebula by the lack of stars, which is pretty cool. I'm gonna dither again here. So I'm gonna pause, view the raw frame. Now I think last time I moved north, so this time I'm gonna move south for maybe just a second. I just want to make sure that it actually moves my mount, because I've got a substantial amount of backlash. So that should be good enough. Looks like the mount's stable, and we can resume and view the live stack again. And if we look at the drift graph, we should see a new location. Yeah, so right here we're starting to get new frames aligned on that point. So it's been about 11.5 minutes. Gary's talking about plate solving, which is another fantastic tool, and SharpCap has a built-in integration where you can connect your mount to SharpCap, and it'll use the camera, and it'll plate solve. So it'll take a picture and compare it against the star chart, figure out exactly where that picture fits, and then it'll send those coordinates to the mount, so the mount knows exactly where it truly is, and then it can find the object and just dead center, get it perfect. I really want to get that working, but I have an issue with for whatever reason, SharpCap doesn't want to talk to my Onstep'ed mount. It's sort of a do-it-yourself project. This little controller box here has the motherboard from a 3D printer, and it's just driving stepper motors from a 3D printer, and it's all really cheap. But there's a great project where a guy makes software. So instead of the motor controller driving 3D printer motors, or the motors for a 3D printer, it's driving the motors for a telescope mount, and it serves essentially the same purpose, just a little bit different software. But the driver that guy wrote for that doesn't play nicely with SharpCap. So whenever I try to connect my mount to SharpCap, it just locks up. I've been meaning to collect enough error reports to try and ask either the SharpCap author or the Onstep'ed author to investigate. But they're both essentially single authors, so they don't have a ton of time. So we can try to stretch a little more with the histogram here. I'm going to try and sneak up. You can see a lot more sky color now, and this adjustment is very sensitive, so if you try to do it conventionally, it can be a little tricky. But if you hold shift, it acts like a gear reduction, so you can very, very carefully move it. And you can also, there's a button here for logarithmic horizontal axis, and that'll basically essentially zoom in on this lower area where most of the action is. But didn't work so well. If this spike were much lower, then it'd be more useful. I'm in kind of no man's land where the normal histogram axis is a little hard to adjust, but the logarithmic axis is also not much better. If the peak were over here, it'd be easier in the normal mode. And if the peak were down here, it'd be easier in the logarithmic mode. But I'm sort of right in the middle. So previous nights I was using a UV IR filter, and that was giving me sort of improved colors on the stars, which is nice. But because of the smoke tonight, I decided to not use it. I'm thinking that the infrared light hopefully is passing through the smoke better than the visual light, so I don't want to discard that. So you might see some funny star colors. You know, this is kind of purplish. And depending on how I get the color balance, there might be some green ones. But especially for galaxies, the infrared is pretty meaty. There's a lot of signal there. It's nice to capture it instead of discarding it with the filter. I could probably minimize these. What I'd really like to do with plate solving is to make like an equivalent to the star sense. So I want, there's a scripting tool here in SharpCap, and you can write little scripts. And in the next version of SharpCap, he's going to add very basic automation routines, so you can sort of do like visual block programming. You know, step 1, do this, step 2, do that, step 3, do this, if this, then return, yada yada. But what I think would be really cool is if I can automate my startup alignment. So if I can get my mount to connect to SharpCap, I think it'd be pretty cool to make a little automated sequence with plate solving where, you know, first it focuses, finds best focus. I want to make a motorized focuser for it too. And then it'll just point to, you know, preset alt-azimuth coordinates and then advance sort of north and east just to take up backlash on my sort of old worn out mount. And then it can take a picture, plate solve, and then use that as an alignment point, and then go through my mounts procedure of maybe doing 4 or 6 alignment points and build a nice model. Although with plate solving, you don't technically need the model if you can do just a single point and then use plate solve to get you there. But it's nice to have a good model and to land on target. So we're just starting to maybe resolve some darker dust lanes on there too, which is nice. Little patches there. Looks like one right there too. I'm going to try and darken the background a little bit. My preference is to have at least a little bit of sky color there. Some people like to have darker backgrounds where they'll advance it more and kind of clip the object, completely separate it from the background. But for me, I find that kind of loses a little bit of the delicate feathered edge. So I just kind of sneak up on it, but leave a little bit of brightness out there, not much. I'm gonna move the mount again. So we'll pause, look at the individual frame, and this time I think I'm gonna go east. Maybe for 2 seconds. Now I think in the fully automated dithering, it actually randomizes the direction and distance, which is theoretically better, just because the more random the motions, the more the pattern will average out. But in order to do that, I think at least the way that SharpCap can do that, you need to have a guide scope set up. But I don't really need one, so I don't want to bother with it. So we'll resume the live stack and go back to looking at the stack. And it's been about 20 minutes and it's looking pretty good. I usually don't stack this long on stuff, but I'm curious to see how it'll perform. And usually the view improves. It just keeps improving and improving as you look at something, but eventually you kind of hit diminishing returns. So I'm going to save a snapshot of that, and we'll start thinking about a new target. And if anyone has any requests or ideas, you can put them in chat. I'll see if I can take a look. I've got pretty high horizons, as you saw earlier, so it's maybe 45 degrees-ish on average, maybe 30 to 50 varying. Decrease the number of stars just so it doesn't overload my poor little computer out there. And you might see me using this later on. Instead of sort of scrolling and zooming out, these field of view shortcut buttons, they're also bound to the keyboard number pad. So by using the number pad, you can quickly jump from, by hitting number 1 to the number 1's sort of the super tight view, and number 9 is way wide, so you can quickly jump between sort of finder view, camera view, and then object view. Well, these little gray rectangles are dark nebula. So instead of something bright or glowing or reflecting light, it's actually just a completely opaque dark cloud of gas that's just blocking all the stars behind it. But they can be pretty challenging, especially with this low transparency and the smoke around, so not sure how successful those would be. But we can sort of get a little preview with Cartesiel. So if we zoom way in, we can download a picture from an all-sky survey. And my mount out there has a pretty poor connection to my internet, so it might take a little while. For remote desktop, I use a completely independent Wi-Fi network, and it doesn't have any internet with it. I think that one might be a little tough. Maybe we could try it, see if we can get that thin, long wisp. It looks like a decent fit for the field of view. So we can hide that picture, and it looks like that's called B150. So I've already saved a picture of this one, and I don't normally do this, but I think I'm gonna save a FITS image of this as well, just to play around with. So I'm gonna relabel this for B150. You can exit the live stack, and this will be looking at the raw frames. So I always think it's absolutely incredible that the software accumulating frames with a live stack can let you pull, you know, this out of just that little barely there gray smudge. But if you look at it long enough and collect that light, you can see incredible things. All right, so let's point at this object. So I could select the object and issue a go to, and that would try to center the object. But what I'd like to do is I want to try and match this field of view. So if I right click, go to telescope, I can tell it to slew to the chart center, and that should get close to the position I have here. And we can stretch the frames coming from the camera just to see if maybe we'll see that object. I think I see a band here that is lacking stars. So we might have it. And we can look at the brightest stars in the picture, try and memorize kind of where they are, and then compare the view to the star chart. So we've got these two, and then this bright one here is that bright one. We've got this string and that string. So we've got this string and that string. So we're pretty close. Looks like we're maybe a little bit this way, but it's close enough. And if we bring back the preview picture, that looks like it's gone. Oh well. But I think this positioning is good enough. So we can start the live stack. And when we open the live stack, we'll still have the old picture in memory, so we'll clear that out. And I gotta remember to reset this little tiny display histogram so I don't end up stretching it twice. So hopefully it's showing up on the stream, but it's very noisy, but it looks like there's a lack of stars in a band sort of here. You know, not really resolved as an object, but you can tell that there's sort of not nearly as many stars along this path as there are, you know, around it. So it looks like we're on that dark nebula, that cloud of gas and dust. That's just sort of silhouetting. There are stars behind it, but it's blocking the light. If we had a sweet, fully infrared telescope, we could probably peer right through it, which would be pretty cool, or radio telescope. But for the visual spectrum, it blocks the light. It looks like there's the darkest area. It looks to be right here, and there might be another very dark area right there. And we can abuse the histogram and just really stretch it beyond all recognition. But that'll accentuate sort of the extremely faint differences in brightness. So it's definitely a darker area there. But for a more pleasing view, we can sort of back away from that. So we haven't dithered at all, and you can really see that fixed pattern noise that I was talking about. It's almost like there's holes, you know, little patches just evenly distributed throughout the whole view. So if we pause, go to the mount, go north for a second, pause again, make sure that the mount is stopped. It wasn't as much as I wanted to move, but it might be okay. I'm going to nudge it a little more. Go west. Pause. Doesn't have to be much. And now we can resume and go back to viewing the stack. And by nudging the scope that small amount, this weird granular pattern will no longer land on the same spot. So because it's fairly random, by changing position, it should help it even out. You know, as you average something random, it kind of approaches, cancels out. But you need to move farther than sort of the granular size of this. So if I only moved 3 or 4 pixels, it wouldn't really help. But if I moved, 2 or 3 times the size of the grains or the little pattern, then it'll start to average out. And it's usually only really a problem with a very aggressive stretch or a very low signal to noise sort of object, which a dark nebula is. It's, they're very difficult. But we can definitely tell something's there, that long, slender wisp of gas and dust. And I'll just manually dither again. Pause there, make sure it settles down. That should be more than enough. and we'll look for another target. You can see that move was a lot more, and now we're missing a chunk of the field of view. But there's a lot of real estate to work with, so I'm not too concerned about it. This whole area is just chock full of all sorts of nice dark nebula and reflection nebula. This whole area is just chock full of all sorts of... I'm getting an echo off your mic, Mark. This whole area is just chock full of all sorts of... So when you're joining the Discord, you'll want to mute the YouTube video because there's going to be maybe a 10-second delay on the live stream compared to our live discussion. And when you're in the voice channel, if you could wear headphones or to adjust the microphone threshold so that the speaker sound doesn't feed back in, would be good.
Let's see.
Oops, I muted myself on accident.
Oh, that's okay. There we go.
Hey Mark, how's it going?
All right, how are you?
Pretty good.
Is that the dark nebula?
Yeah. So this is B150 in Cepheus. And this whole area is chock full of them, which is great. And this bright line here is the meridian. So as things pass over, we can take a look at it. Looks like there's a couple planetary nebula in there too.
Are you up near Cassiopeia? I can't tell.
I am between Cygnus and Cepheus.
Oh, okay.
All right. Cassiopeia is over here.
Yep. Oh, all right.
This is in equatorial coordinates. So it's almost like we're looking over our back, pointing north. If we go into alt azimuth, it's a little more relatable. So these are the trees and stuff to my north.
Yep.
There's Cassiopeia there, starting to rise.
So you're looking more over you're looking over your back, right?
Yeah. So in equatorial coordinates, it's kind of upside down compared to feet on the ground.
So Jupiter would be
to the south, sort of.
Yeah.
Way down here, but I've got really bad trees. So if I point it at Jupiter and then switch into alt azimuth, it'll overlay my horizon.
Oh,
so I've just got this teeny tiny notch between the trees. So when I want to see something to the south, I have to time it just right. And I only have maybe a 15-minute window where it passes from one side to the other. It's kind of a bummer. But for that stuff, I usually go to a remote field, but I can't live stream from there.
Well, you've got a better sky there tonight than I do here, because not only do we have the smoke, but it's fogging up here a little bit. It's not like a thick fog, but it's there's definitely a lot more humidity in the air tonight. So I'm surprised you can see this. I mean, that's pretty good.
I'm very surprised. When I set up and did my star alignment, there was definitely a lack of stars compared to the stream 2 nights ago. And looking at the wide field camera, it's kind of more flat, more murky. Can't really see the Milky Way. And you can actually see that tree that was showing up in the alt-az mode.
I think I might ask you this the other night, but are you using the wide field as a guide as well, or is that just a wide field camera?
Just a wide field camera. So I could, if I put a longer focal length lens on it, or if I mounted it into a guide scope lens, it could be used for guiding. But
is that a 120?
This is a 290 mono. It's not a ZWO camera. It's a Rising cam off of AliExpress. They're sort of budget versions. Their 290 mono is maybe 250. Not a whole lot cheaper than the ZWO version, so
Yeah,
it's
I
not
have.
that
I
big of
have
a deal. But their
Yeah, I have a
224 is
now.
really cheap.
What is the so what are you using for the lens on the front of that? Is that just the wide
It's similar. So it's the same socket type. So it uses a CMount lens, but I have a 5 millimeter lens that's IR corrected. So not all lenses are designed to focus visual and infrared together. A lot of them
Yep.
depend on the sensor having a IR filter to reject it. But the astronomy cameras don't have that filter. So a lot of lenses end up having really bloated stars. But for security cameras, for day-night sort of video, it's important that they can focus both visual and infrared,
right?
because they have the infrared illuminators at night. So the security camera lenses are fantastic for all sky cameras because they're pretty sharp. So this is just a
I'm
wide
noticing.
angle security
Yeah,
lens.
your trees have that kind of whitish infrared look.
Yeah. So I think this would be, yeah, this is the tree behind my house. I bet I could shine a flashlight on it. It would light up. But the neighbors across the driveway have a small floodlight in their backyard they usually leave on, so that's probably reflected light landing on there.
Gotta love it when the neighbors leave their lights on after a certain time, right?
Yeah. At least his yard is completely overgrown, so it doesn't shoot much light up.
I've seen pictures of this, or these dark nebulas that are really, there must be longer exposure photos because you can actually see the,
Like brown color and stuff.
right,
Those are
the
incredible.
actual gases. Yeah, they are incredible because you think about it, look at that. It's like, you know,
It's like photographing the absence of light, which is kind of difficult. But to be able to pull out color and detail in those professional astrophotography pictures is incredible.
you could do it, I think, but you'd have to do longer exposure and
Yeah,
and
more
stack.
setup.
Right. Yeah, I think the 290 or the not the 290, the camera. What do you have? The 12. It is.
I have this one is a 290.
The 294, right? So.
Yeah. Oh, sorry, 294. Yeah, the
Yeah,
wide
you
field
could
is
definitely.
a 290. The telescope is a 294.
Cool.
And I don't think I dithered enough. You can see there's those little patterns, and it's starting to elongate east to west, getting a little stretched out. Just not the stars, but that sort of mottled texture. And if we go to the drift graph, we can see that, you know, my mount has very poor periodic error, so it tends to wobble around east to west. So if I was critically trying to observe this, I probably would have dithered a little more. But
now, do you have a filter on this camera at all?
So right now I'm using no filter at all. So the camera itself has no filter built in, just an anti-reflective coating. And the Bayer filter that's used on the color pixels, they begin to pass infrared beyond maybe 750 nanometers. So they actually become a little bit sensitive to it, but the total sensitivity starts to drop off, so you only gain a little bit. But it's nice for tonight with the clouds and the smoke. It might let me get a little bit through there because the infrared should pass through.
Well, that's what I was asking with the you know, the smoke particulate in the air. You're still getting pretty good star, you know, quality.
Yeah, I'm very surprised at how well it's doing.
I gotta tell you, between the coyotes, the skunk, and the raccoons, It's been interesting setting up my scope out there.
Yeah, this year I've had a couple run-ins with our skunk, although he's seems to be peaceful. It's not very
Oh no,
observant though. No lights,
this
no
one,
difference. You gotta kind of tell him to go away, and he'll go away. But
yeah,
shining a light on him,
this
it's no difference.
this one's definitely friendly. He came walking up the driveway, and I pointed a light at him, and he looked at me and turned around and walked back. Same with the coyote. I tried to get the French program running. It supposedly runs on. Yeah, it supposedly will run on my Mac, but for some reason it won't. It's not letting me download it. I'm not quite sure why. I have to look into that because they do have a Mac version. I did watch the video of the SharpCap guy the other night. That was very informative. Thank you for
that one was a really important video for me when I saw it, and it all kind of clicked, and I was like, oh, it made choosing cameras and optics specifically for short exposures. It really helped inform the decision-making process on that. There's a lot of good insight there.
The whole thing about the diminishing returns, that after a certain point, cooling your camera or
under light pollution,
right? You have to kind of know a little bit of both of those to decide whether, it doesn't matter how cold your camera gets if your light pollution is defeating that.
Yeah, if it completely overwhelms the thermal noise. So I'm looking for a planetary nebula, and it looks like it's kind of right in the middle of these three bright stars. So somewhere in here. Let's see if we can see it. A lot of these are absolutely teeny tiny. And without filtering, they can be hard to spot. Let's see.
My Triangulum Nebula, which, by the way, is the same as the pin. Wait, go straight forward. You got it there. If you go straight in, I see something that looks like a planet, unless my glasses have got dirt in them. If you go keep going. Yep, right, up a little bit. Keep going to your left just a little, and then up. Nope. Yep. Right. Nope. Back to your right. No, is that a double star though? It's hard to tell.
We can do a download a survey picture here just to see what we'd be looking for. So it should be about maybe 40 pixels wide on my camera, and it looks like it might be a dim one, so maybe we'll just go live stack it, or we'll auto stretch. That might help. It should be somewhere in here. We'll see what shows up. We'll start a live stack. I mean, I know it's within the field of view, so if it's there, it should show up. A lot of these planetary nebulas can be very, very tiny. I just saw it.
Yeah, I didn't. Yeah, right where your cursor was there just a second ago. Right in there. I'm thinking that's where it is.
I think maybe right here. See a very faint glow.
Yeah.
Just gonna check the
somewhere.
star chart.
I think to the left there a little bit, maybe. Or somewhere right in there. You're close. There's that. There are the 3 stars. I see that. So yeah, it's got to be.
Yeah, it's just starting to show up. I think it's these stars here. I think that might
Yes.
be the central star. It's
Yep.
extremely low surface brightness, very faint. I'm not sure if we'll be able to pull it out. You know, the difference between the surface brightness and the sky brightness is less than the modeling of my fixed pattern noise. So the manual
Yep.
dithering might be critical to do here.
I am
we'll
seeing it though. You're right. Where those 2 stars are, it's very dim. So you move the scope slightly just to redo the fixed pattern noise?
Yeah, so that sort of almost granular modeling that we see, where there's sort of dark spots, that's called fixed pattern noise, and it's sort of the leftovers after calibration. And that is sort of fixed relative to the camera sensor. So if we keep looking in exactly the same spot, that pattern will kind of burn itself into the stack. But if we very slightly reposition the telescope so that the star, you know, that pattern gets shifted relative to the stars, the live stack will always line up the stars, but by shifting the telescope we can shift that pattern and it'll start to average out and smooth out. So it looks like we might barely have it there. A filter would greatly help for this object, and maybe longer exposures.
It's right, yeah, it is right there.
Just barely threshold.
Yep, yeah, there it is. Now you can see it.
And the number on this one was NGC 7076.
It needs a more dignified name than that.
Yeah, it might have one. A lot of the planetaries have interesting names because they can be pretty detailed. That one was kind of a bust for this setup and this scope. Let's try 7139. So we'll exit the live stack. We'll hope that this one is a little more apparent.
So you might have me sold on the 208 Newtonian.
I think they're fun.
It's big though. It's a big.
I think it's about as big as you would want to go to lift onto a equatorial mount. Anything bigger and it becomes sketchy to, you know, lift it up into the saddle and hold it there with one hand while you tighten the saddle bolts.
Yep.
And 8 inches is plenty of aperture. Even I had a 4-inch Newtonian. So before I got the 294 and the 8-inch, I was using these smaller 1/3 inch cameras with the smaller Newtonian, and it was a really nice pairing. Actually, I've got a picture of the setup.
I was looking at the 6-inch as well, but I didn't think the 6-inch would be quite enough.
Yeah, it depends on the pixel size. So, like, for example, this was I had a 224 color camera and a 290 mono camera, and this is just a tiny 4.5 inch f4 Newtonian, a Meade Mini light bridge, but the combination worked pretty well. Even though it was a small sensor, the short focal length let it have, you know, a reasonable field of view, and it had decent sampling of like 1.7 arc seconds per pixel and 1.4 or 1.2 because the mono had smaller pixels. But let's check for that planetary here. So we should have a bright star over here and a bright one there, and then maybe 2/3 of the way. think I see it right here. It's very faint, so we'll go straight into live stacking. It's another spread out dim one. Sometimes they can be extremely concentrated and very bright. You know, you get the opposite problem. They're too bright and you have to sort of slow down the exposure, and by the time you zoom in to look at them, they're pixelated, so they need a little more focal length. I think we definitely have it there.
Yes, I definitely see it. It does kind of look like the other one in the sense that, you know, it's still pretty dim.
Yeah, the surface brightness is pretty low.
And size compared to, say, Pac-Man. Pac-Man's pretty big.
Yeah, so I think Pac-Man maybe takes up this much space. I've got, actually, I can pull up a picture from a couple nights ago. But this is looks like a pretty faint planetary nebula. And the transparency, the smoke overhead really doesn't help. It's not doing us any favors. On a clear night, it would probably be a lot more apparent. And the pattern noise would be less apparent just because there'd be more signal to kind of flood it, overwhelm it.
No, it's definitely there. Yep.
So I think I looked at it. Yeah, here's an image from 2 days ago of Pac-Man, and that's the full field of view of the camera. So it's almost half the height of the camera, the field of view, where this one's pretty small in comparison. A lot of planetaries are teeny tiny.
I wonder what they called Pac-Man before Pac-Man, because as I said the other day, I've been alive before Pac-Man existed, and you know, there must be another name for it, unless somebody just found it.
I don't know. I wonder, because it's hydrogen alpha mostly, so it'd be difficult to discover visually. I wonder if it was discovered by photographic survey with film or glass. Maybe the cluster toward the middle has been discovered in the slight reflection nebula, but I wonder if the full extent of the red hydrogen alpha.
Well, let's look it up. We have the technology. See if there's any information. So, boy, the Hubble photo of it, it's quite a complex nebula.
Yeah, especially the Bach globule, that dark, opaque, dark nebula. I think there's some fantastic Hubble close-ups of that, looking for protostars forming in there.
Yeah, the Spitzer image shows, but that's X-ray and
peering
IR,
through.
so it's, yeah.
Let's check out this pair here.
It was discovered, by our friend Barnard in 1883.
Wow. The cluster or the whole nebula?
The nebula discovered the nebula in August of 1883, describing it as a large, faint nebula, very diffuse.
Hopefully this one will be a little more apparent than the other one. This should be a brighter reflection nebula, maybe a little emission, I'm not sure, and a star cluster. And again, the transparency is not really doing us any favors.
Oh yeah, there it is. That looks more like a Pleiades style.
Yeah, almost like a little mini Pleiades.
Little mini
like
cluster.
Small cluster with some gas and dust around it, so it's reflecting off the dust.
Yep, that almost looks like Pleiades. Interesting.
Almost has a full ring of stars around that one. That's pretty cool. I wonder if that'll show up in the planetarium.
Yeah, as to whether those stars are in the background or whether those are actually part of the cluster. It almost looks like a cluster with a nebula, like I said, like the Pleiades.
Yeah, so it might be in and around some gas and dust and just the intense starlights bouncing off of it. And unfortunately, it doesn't give any distance data, which is too bad.
But they look like those might be red. Are those color-coded by this type of star?
By the spectral class, or the BV color.
Yep. Yeah, that's interesting. It is almost like a Pleiades, like a teeny tiny. There's a very interesting article on astronomy.com, the magazine's website, about that shows, and I think the program that you turned me on to the other time, the space engine, where it shows the actual three-dimensional distance of all the stars. I think it's within 30 light years of us. It's always fascinating to put three-dimensional depth into a two-dimensional image.
See it as a volume just completely surrounding us.
Right. And that Barnard star, I think it's Barnard. Maybe it's not Barnard.
Oh, yeah, I think that's not too far from here.
One of them is going to come into our. It will come in past the Oort cloud in its orbit. This was long before or long after we're gone, but they've calculated that has happened once before, that we had a star go through the Oort cloud, and it could have been part of one of the dinosaur extinctions. Oh, there you go. That's very nice. Oh, nice. Oh, look at that. It is like a Pleiades.
little bit of sort of structure to the dust cloud or gas cloud right there. Sort of rim lighting, direct impinging light from that star.
What is this one? What's the
let's see. I think
NGC
7142. Oh no, 7129. The larger cluster down here was 7142.
That would be a good challenge. Because it's kind of cool, because like you say, it's almost like a little mini Pleiades out there.
Yeah.
Who comes up with those?
The numbers?
No, the challenges.
I think it's a team I think Roger Ivester and Sue French work together, and there might be suggestions from other people.
All right, here you go. It is a reflection nebula located 3,300 light years away in the constellation Cepheus. A young open cluster is responsible for illuminating the surrounding nebula. So it is just like a recent survey indicates the cluster contains more than 130 stars less than 1 million years old. There you go.
Wow, babies.
But think about that. There's 130 stars in there.
Yeah, hiding.
Yeah. 3,300 light years is not that too far.
Yeah, I think Orion Nebula is 2,500 or something like that.
Yeah, so it's in the neighborhood.
Yeah.
That's cool. That's a very cool nebula.
I wish I had put a name in here. For whatever reason, this new version of SharpCap, I think it's a bug, but you can't change the name once you're stacking.
If you get a chance, Wikipedia that one later, because there is a very cool, it almost looks like squid tendrils coming out of it would be the upper, let's see, let me look at these stars here. It would be the upper right. There's like a squid tentacles coming out in a, I forget, is the purplish, is that hydrogen alpha?
Yeah, the pink, usually it's portrayed as kind of red pink if it's close to actual color. But I think sometimes with the Hubble palettes and other different types of artificial colors, they make it whatever color they want. So you can't always trust the images.
It looks kind of like a fish. With, yeah. You could do a Rorschach test on that to see what people see in there. Have you ever? How close are we to the Ghost Nebula?
Ghost. Do you know the number? That's another thing with Cartesial. It doesn't have many of the common names. I think it's somewhere in here because there's tons of dark nebula.
7023. That might be a difficult one to see because it seems like it's mostly darker dust.
Hey, it's not that far at all. It's something I've always wanted to try.
Well, there you go. 7023. It's only 550 light years from Earth, so that's really close.
Wow. So I'm gonna just clear the stack and hope that the telescope landed on target. We'll see how accurate it is. Usually it's pretty good. I've got a wide enough field of view that it's fairly forgiving. Huh. Looks like I've got a bit of a reflection on that star there.
Oh, is that it?
I think so.
Yeah, it looks kind of like what I'm seeing here. There's a star, looks like it might be a double star system just to the, yeah, that's pretty bright. It says bright nebula.
You can start to see some light sort of falling on the gas and dust around. Looks pretty volumetric in 3D. I bet it'll clean up nicely.
Oh yeah, it's I can see why they call it the Ghost Nebula. It's very pretty. So let's see. Yeah, there's a star that's slightly. Oh wow, you're getting a really nice image of that. Beautiful. Trying to see. Yeah, beautiful.
You can definitely see sort of darker area around it that is just lacking stars compared to the field. You know, all the stars out here, and it looks like there's some dark nebula all throughout here, kind of engulfing it.
The bright star in the center, which is actually not in the main center of the nebula. It looks like it's behind the nebula, and that's what's lighting up the nebula. So that what you see right in the center is slightly off center from the actual nebula.
The cloud of, yeah, it looks like if I were to outline it, it might go kind of here. Just the dark nebula. Actually, I think I've got ink. Not sure how this will work. That doesn't work so good. Let's try this.
Yes, it looks like they're. Okay, those are the 3 stars at the bottom. So there are those 3 stars. Yep.
You can kind of see a silhouette of a dark nebula.
Yep.
Kind of like that.
Yes, it's a. But the main part, the part that I'm seeing in most of the pictures is the milky. Almost looks like a milk and tea. Oh, there you go. There now. Very, very bright star lighting it up. Oh, there's 2 nebulas. I guess next to it is the Iris Nebula. So in the wider field, it looks like to the.
We're sure that's not the Iris? This one here?
That we're looking at?
Yeah.
It could be.
So I know there's a dark nebula that looks like 3 Halloween ghosts sort of lined up next to each other. I'd never remember the name of it, but it's something I've always wanted to try for. It's a good fall theme.
This says the Iris Nebula and the Ghost Nebula. So it looks like there are 2. One looks like a face. So you might be looking at Iris, although it doesn't. And then the Ghost would be. I don't know whether you're looking upside down or not.
It looks like it could be a nice spiral galaxy, not too far. NGC 6951.
Yeah.
We'll take a look at it.
Cool.
So I think I got a snapshot of this one. I'm curious. I'm gonna disable my flat frame. I'm still sort of learning flat frame. You can see now that I've got a little bit of a vignette. So this is closer to the raw image that's landing on the sensor. I'm just curious if that grain texture is part of my flat frame or not, whether it's something I accidentally introduced. I think this seems smoother. It's hard to tell. So that fixed pattern noise, I may have accidentally captured that in my flat frame. So if you have any issues with the flat frame or the dark frame when you're capturing it, say some light leaking in that shouldn't be there, or some issue with the flat frame where it's not uniform. So if you capture errors in those frames, because they're used as calibration frames on your primary image, they'll actually ingrain those errors into your image. So it looks like maybe that granular fixed pattern noise that we were seeing may have been associated with my flat frame, because this is looking a lot smoother when I'm not using the flat frame. So I might have some work to do.
I thought I was dealing with professionals here. Come on.
Yeah. So this has been 16 frames, 2 minutes without a flat. I'm going to turn the flat on and see sort of side by side.
This is still the ghost, or are we looking at the
this is a nearby spiral nebula, or spiral, yeah, used to be spiral nebula. Now we call them galaxies. This is a nearby spiral galaxy, NGC 6951. So I'm gonna clear it out. I turned on my flat frame. I'm curious to see if that gritty texture is part of the flat frame, and I think I can already see it. So it might just be.
It's a barred galaxy. It's 70 million light years from Earth. Not super. It has a very bright center, but the outer arms are going to be hard to see. Magnitude 11.8 at its absolute.
It looks like the pattern is definitely part of my flat.
Seifert Type 2. No, wait, that's 6951 you said? Yeah, Seifert Type 2 galaxy.
Does that mean it has an active nucleus? I'm terrible with the classes and.
Yeah, I think so.
Like a black hole, or probably a black hole in the middle.
It's interesting.
Or a radio source.
In the Sky and Telescope picture, there's actually a cloudy nebula in the foreground, which I wonder what that would be if they have the label on that, because it's obvious in this picture that it's not a dark nebula, but it's more like that ghost nebula where it's like a milky cloud. Yeah, you were just seeing one of the arms there, it looks like. I can see that. Pretty galaxy.
Yeah, I love spirals. I like barred spirals that have a ring around them. I always think those are really cool. Or this one has sort of normal spiral arms coming off, but a fantastic shape.
Okay, so there is a integrated flux nebula in front of it. The residual light of our galaxy illuminates this faint nebula. The galaxy is also categorized as NG 6952. This guy did an exposure time of 750 minutes, 25, 30 minute exposures. Well, that's why you can see the diffuse nebula in front of it.
Hmm.
It's a nice photo.
Now here you can, when I zoom out, you can really see the vignetting. So
Yep.
with the
Oh, yeah. Yep.
with the very neutral stretch, it doesn't look that bad. But when you start to actually stretch things, you exacerbate any minuscule difference in brightness across the field. So it becomes a lot more apparent. So that makes either having a telescope with a very flat and even illumination very important, or taking and using flat frames are very important. And you can see I've got a little shadow of a piece of dust or something there, a little donut shape. And another one here and another one there. So I might go outside and capture a new flat using some different settings to see if that helps. It'll probably take me 5 minutes or so. So
while you're doing that, see whether I can download this star chart, figure out what's going on with this.
yeah, the cart to seal can be pretty clunky as far as user interface, and configuring it takes a long time. But it's only because it's so customizable. You can make it do almost anything you want. I'll be back maybe 5 minutes.
Watch out for the skunk.
Yeah, I'll definitely go down there with my light on. Yep. All right, we'll see if that worked.
I got the carte du soleil to seal. Carte de seal to work.
Nice. Was there a trick to it, or just had to retry?
You just had to. I just had to tell the Mac that if the Russians have put malware on this, that I was still going to let them do that.
Yeah, you gotta do the same thing on Windows, just because it's a open source project and they don't have proper certificates or something. All right.
Is the Pleiades up yet?
It might be in the trees for me, but we can check.
No, I'm just looking at the map here, and I'm trying to figure out whether it's. That's what it looks like, but it's hard to. I'm still figuring this out.
Yeah, it took me a while to get the hang of it. I didn't really like it at first because it was so clunky, but
well,
I'm starting to come around.
It doesn't really have a zoom control.
If you hold the mouse wheel should zoom. At least it does for me.
Well, remember, I have a Mac.
Does it have a ball? A mouse ball?
No. You're. Oh, okay. Wait.
Or if you use 2 fingers on the trackpad, that might zoom.
Yep. Yes, Yep. Just a little slow sometimes. That's all.
All right, I'm gonna try to recenter on this thing, and we'll stack it again and see if I've got that fixed pattern noise.
Which one was that? 62691?
This is correct.
Or 6952. It goes by either name.
Huh.
Interesting. So this doesn't give you information on
Yeah, not really. So if you click on it or double click on it, yep, or when you click on it once, the little black box will come up with the name. If you click in that box, an info window will come up, but it's mostly like database information on location, size, magnitude. But if you scroll all the way down to the bottom, there are links to websites. So you can go straight to like Sinbad, Visar, Ned, and get the actual scientifically peer-reviewed data on it.
Yep.
But it's a little clunky for kind of surfing around, and I don't always have internet access if I'm operating remotely in a field. So Sky Safari in my pocket is usually pretty handy for that.
Oh, did we look at 7023? Is that the one we were just looking at? Yeah.
All right, so should be back in business. We'll clear that one out. This is a little bit of an experiment, so we'll see.
I also found this very interesting app where you can. It's kind of like one of those where you start on somebody's hand and you zoom all the way out to the end of the universe, and then you go back all the way in and you zoom all the way into the
like a powers of 10 video.
Yeah, it's like a powers of 10, but it shows the size of the star, the different stars that are out there, and what is the biggest star, and it's the sun is not even is like a
Yeah,
dot compared.
it's incredible. I forget the name. It's like VW something. It's not the biggest star anymore, but I remember watching a video where it kind of panned out from the Earth to the planets to the sun, and then through, you know, the common big stars like Betelgeuse, and then it went on to the super crazy massive stars.
This app is called Universe. It just came out.
Nice. Is it Apple only, or maybe
I don't think so. No, I think there's an Android version of it. Let's see. The biggest star, because this just came out.
I'm gonna look for a new target in the area. Let's see.
This also shows the relative size of the most popular nebula, which is kind of cool as well.
Oh, cool. Absolute size, like one next to the other one?
Yeah, it compares it to, like, for instance, the North American nebula is compared to the Cat-Eye Nebula is huge. And then the Lagoon Nebula is even bigger than that. Yeah, this is a very cool app. Yeah, I think there is an Android version of it.
Nice. I'm going to take a look at some of these open clusters. Hopefully they'll punch through the smoke a little better. Actually, let's take a look at this carbon star. And for these, we can probably just directly view the live frames.
The Rotten Egg Nebula. That'd be interesting. Wonder where that is.
Is it a planetary?
Yes. These don't have the NGC or anything, so you'd have to just, you know.
I think this is called the Garnet Star. It's a really, really red carbon star. It's really cool in the eyepiece of a telescope. It's like noticeably, substantially red.
All right, so the largest star known, at least according to this app, is called Stephenson 2-18. It's 3 billion kilometers across, or in diameter. Yes, across, or diameter, I guess. Polaris is pretty big. I always thought Arcturus was really big, but it's kind of like, eh. What star is this?
So I was looking at the Garnet Star, Mu Cephei, I think. Cephus, which is a carbon star. And they're really, really red. But now I'm just surfing through some of the open clusters in the area.
I'm going to try to find out where Stephenson's star is, just so I want to see whether it's in the northern or southern hemisphere, to see whether you could look at the largest star in the universe, the known star, excuse me.
So this is NGC 7261, and we'll just kind of surf around to the nearby clusters
929.42 million miles radius.
It's nuts. It's a nice small little cluster. Almost looks like a tiny mini ET cluster, NGC 457. The proportions aren't quite right, but looks like a nice cluster.
In the constellation of Scotum. Scotum?
I think that's near Sagittarius. It might be setting in the west now.
It's up. Yes, it's above Sagittarius at 10 degrees.
Yeah, it's in the trees for me. I might live stack this little cluster. Looks nice. It was 7234.
It's in the cluster known as RSGC2, an open cluster in Scutum.
I wonder if that's in. There's an expanded open cluster catalog for Carte de Ciel that goes beyond the normal Messier and NGC and IC.
Well, let's give it a try here.
Oh, I accidentally double stretched this again.
Nope.
I'm going to give the Fireworks Galaxy another shot now that the flat frame is no longer being problematic. Or less, at least it's being less problematic.
Are you able to see the whirlpool, or is that
That's too low. It's setting in the west.
That's M33?
M51.
Okay, so Scotum is, let's see, what is 240 degrees? Is that, I should know my compass.
240 is a little south of, it's like southwest-west.
$15 degrees above the horizon right now, which is pretty low.
Yeah. I'd say on average I probably have a 40-degree horizon with notches that go down and up.
I have open all the way from southwest to southeast, and then
Nice.
I have probably maybe, well, I can see just below Cassiopeia to the north, but not much. And then to the northeast and northwest, I have trees. So I have to have stuff that's either right in between the trees or Because I'm setting up, I'm kind of on a hill. The house is on a hill, and there's big giant pine trees that when my family first moved here, there weren't.
Missed opportunities for a free Christmas tree.
Yeah. Oh, my mom's neighbor keeps saying that he's going to cut down some of the pine trees, which he's letting all these vines take them over anyway. So I think they're going to eventually just fall over anyway.
Get strangled.
I've been actually keeping the pine trees near us from dying because he doesn't
Risky.
cut the vines off, and they're just strangling the pine trees. But
So I think this is definitely looking better now that I changed my flat. I was previously using what's called a dark flat. So when you figure out what flat exposure you need at the whatever gain and whatever exposure time, there's a method where you take a dark frame at that exposure time and gain, and you calibrate the flat frame with that dark. And it's supposed to help with the 294 and the weird way that its bias works or doesn't work. And supposedly it was supposed to help, but it didn't seem to help. So this is just a plain normal flat, no bias, no dark flat, no nothing. That seems to be a lot better.
I actually imaged this the other night. It was a bit of a smudge, but I was able to see some of the arms slightly.
Nice. What focal length?
That was the 102, the Explore Scientific 102.
Nice.
And I was using my A7 III, the Sony, because I find that's full frame. So
yeah, that must be beautiful. The big, giant, wide, rich fields of stars.
It's interesting because I find that I'm not sure what part of the scope I'm seeing, because when I would line up on it, I think it was more of my tracker than the scope. Or it's the field of view of what the actual scope is putting onto the full frame image.
Mm-hmm.
Oh, there you go.
There's definitely less of that modeling than there was.
Pretty galaxy.
Yeah, it's beautiful.
I haven't hooked the A7 up to my 8-inch yet, my Ritchie Crichton. That's the next thing I'm going to do. I'm very curious to see how it works on that scope.
What mount are you using?
I had to buy a T-mount for the actual DSLR, and then I had to, as with all of these hobbies and my business, the television business, I had to buy yet another mount to adapt that to the actual scope.
Yeah, I mean the go-to mount, the tracking mount.
I have a Celestron AVX.
Nice. I think that one's a little beefier than the mount that I'm using, which is nice. So the the Super Polaris that I have, it's only rated for 15 pounds, but with the short exposure live stacking, you can kind of get away with some sins. So the Newtonian weighs about 25 pounds with the camera, and I've got a 25-pound counterweight on this poor little 15-pound rated mount. But because it's only taking tiny 8-second exposures, it handles it okay.
Is that the wide field camera?
Yeah, so this is the wide field camera. It's a Ali or a RisingCam 290 mono from
You
AliExpress.
added that lens.
Yeah, so I put a little lens on it, and I 3D printed a lens hood for it to match the field of view. Although this is an older lens, that was a 8mm or a 25mm. I don't remember what I was using, but now I'm using a 5mm to give an even wider field of view. The only problem is the field of view is so wide that it actually would see the side of the telescope. So I had to print another mount that moved it radially outwards and axially forwards by 3 inches, and that makes it clear the front of the telescope optically, so it doesn't end up in the field of view.
My specialty as a television cameraman has been a handheld camera person, so the joke is that I always have wide angle lenses on, and it's so wide I can always see myself, so
It seems to be doing a lot better with that patchiness, but I'm still gonna dither it. I just want to make sure I move it the right direction, just because I'm pretty close to that one side. So I'm going to match the field of view, and I just want to make sure that I'm in the same orientation. It looks like I am. So I want the camera to go west.
you must have a relatively big hard drive on your computer, because the Gaia catalog is what it looks like.
Big. So I only have the north and the equatorial part. I don't have the southern part, but it's like 30 gigabytes or something like that. I forget, but it was a big download.
If you get all of them, it's like 45 gigabytes.
Yeah,
Which
I believe
sense.
it.
It's billions of stars, so. Now, do you have the deep sky in there as well?
Yeah, the extended deep sky. But with the Gaia catalog, it's crazy. If you pan around the Milky Way, you can just crank up the number of displayed stars, and you can just see the dark nebula just by the lack of stars. Although the computer really suffers because it's rendering like 2 million points. I think this is already looking better than that first attempt with the modeling.
Yeah, it looks very, considering it's so smoky and hazy.
Yeah, I gotta keep remembering that.
I actually think that might be why it's looking a little on the tanner side. I don't think that
it would be more blue otherwise. Maybe the blue is scattering out.
We are looking through
Yellow kind of haze. If I had a filter wheel, I'd be curious to see what would happen if I put in the UV-IR filter and to lose all that infrared, that near infrared that the unfiltered camera accepts. So here is the previous one. This was 1200 seconds. It should be 20 minutes. And this is only 9 minutes. This is at the beginning of the night.
Oh, okay.
But this was also with the problematic flat frame that was causing some modeling. And this is about 20 minutes, and then this is only 9 minutes.
Interesting Harvard Science Book Talk coming up on Wednesday. Neutron stars, the quest to understand the zombies of the cosmos. They, Harvard does a science talk. I don't know if you've ever been to any of those. They're really good.
I haven't made it to one.
Yeah, I've seen a few members when we were able to go.
I think one time I participated in like a science day fair that they had. We had some solar observing followed by nighttime observing on the roof. It was fun. I think this is definitely doing way better than it was earlier. The background is a lot more even, not as nearly as much modeling.
I think what you should do is take a picture of these and then you can find a supernova.
Yeah, there's a fantastic website for, I think, Rochester Astronomy. They list the most recent bright supernova. I'll check and see if there's anything going on currently. But with my limited horizons, a lot of times they're not visible. Or half the time they're from the southern hemisphere.
On the cart, I just added the DSO. When you install it does it automatically update the program? Or do you have to go in and tell it to put that in?
I don't remember. I think there might be an update procedure within the program. Like you tell it to monitor a folder and it checks. So it looks like there's a couple NGC galaxies that have supernova tonight. So I'll check these and see if they're visible. It could be fun to hunt them down. So are you using the cart seal to control your telescope? I am. So I have it connected to my ASCOM driver. So up here there's some telescope controls, and one of them is connection, and you can go and select what ASCOM driver you want it to connect to. And once you connect it, then you can issue go-to commands. And is that through Wi-Fi? Mine is through Bluetooth to the mount, from the computer to the mount. It could be a USB cable. But looks like one of these supernova in was it NGC 6930 is visible, should be visible. You can check the wide field, it looks clear. So I'm going to save this and rename. Let's clear this out just to see if we're on target. And this would
that's very nice.
Oh, I forget what galaxy. 6930.
So my friend that was watching the other night had a question.
Oh, that was wrong number I put in. Sorry.
That's okay.
which was with your setup, you can still do regular stacked photos, right? So if you didn't
Yeah.
just want to look around, you can still do actual astrophotography with this setup.
Yep. So I could either using the ASI program or any of the other imaging control programs set it up to take longer exposures and to save those to a folder. And then in the future, I could open the folder and process it. The only catch is my mount is not good enough to do long exposure.
Yeah.
So I would need to do auto guiding, and even then it would be iffy. So I could only really use shorter exposures, maybe up to 30 seconds. And to do a conventional astrophotography where you end up looking at something for maybe multiple hours, if not tens of hours, it would end up with many gigabytes of data because each individual 30-second picture, doesn't matter how long the picture is, each file is like 25 megabytes, 30 megabytes. So they'd add up pretty quick.
Okay, thank you.
But
wait, is that that's the, which galaxy is that? Is that what we were just? No,
this is NGC 6. Oh, sorry.
There's two of them.
6930, I think. Yeah, there's definitely two here. I mistyped it, and I should be looking for UGC 6930. But these look pretty nice. Looks like this one might be interacting with something, or it might be a background.
Oh, is this where the supernova is?
No, I mistyped. It should be a UGC, not a NGC. So I got to keep looking. Seven in the trees. Let's go 7722. That one's visible. How about 7125? Not visible. So let's go for this one. I'll probably have to do a meridian flip to get there. Well, there's one more I want to check on.
Explain the meridian flip.
So,
is it because your telescope is literally looking behind itself? So when you're looking to the north, you're looking at stars that are from south to, up is north, south is down. But when you go to the other horizon, or the other part of the horizon, is that the meridian flip?
yes. So it's a limitation of a German equatorial mount. So currently, the way this mount is pictured, my declination axis can rotate the scope sort of, it'll rotate around this axis.
Yep.
And the right ascension rotates along this axis. So currently the scope, if I were to make a line or a plane that divides the sky in half from north to south, in this orientation, the scope could look at anything on this side of the meridian, that line. But as I look at something closer to the other side, the telescope would start to get lower and lower, and the counterweight would get higher and higher, and eventually the telescope would crash into the mount. So the only way you can look over there is if you reverse, essentially flip the mount around and put the counterweight on the other side.
I've had that problem. So you literally have to reconfigure the mount.
Yeah, well, it can be done automatically. So let's check out NGC 772, and when I tell it to go, what's going to happen is let me maximize this. what's going to happen is right now the telescope is pointing out here somewhere to the southwest, and the telescope's going to maneuver sort of, it's going to come back toward the north celestial pole, and then it's going to flip onto this side, and then I can maneuver. So if you imagine starting the telescope, the counterweight is down and the telescope is pointing to the North Star. When you start using it, it'll go to one side or the other and look at stuff. But if you reset it back to that starting position, you can easily go to the other side of the meridian. And that's essentially what the mount does to itself.
And where do you tell it to do that?
So with it can be different from mount to mount, but with my mount, it's automatic. So it knows that it's on this side of the meridian, and it has a little bit of buffer. It can cheat and go past the meridian and look maybe, I don't know, 7 degrees beyond, but anything more than that, it can't. So if you tell it to go to something that's more than 7 degrees over the meridian, it knows that it has to do a flip, so it'll automatically go through and do it to get there. So if we tell it to go and watch the wide field, let's put this over here, we can see both. So right now the mount is doing a meridian flip, and the North Pole is right over my roof. There it is there, just passing through the crosshair.
How do you polar align?
Carefully. So I have visibility on Polaris, but it's very close to my roof, just barely. That's as close to the house as I can get the mount. But if I could put the mount farther in my driveway, but then my southern horizon would suffer because I'd get under the trees.
Yeah, that's kind of I have one point in my driveway where I live now where I can see the North Star from very close to the house, but I lose a lot of the objects that are, behind the house. So I've had to find this fine line between, too far away and when I decide to try to go wirelessly connected to the scope, I'm going to have to figure that one out. As to what, I have clear view from where I'm sitting right now to where the scope is. So, and it's probably maybe 25 yards. So how far is your one wireless connection from the scope?
1 second. I just gotta write down these numbers.
That's okay.
So it's 2020 SSF is the supernova, and it's in NGC 7722. And I'm gonna start live stacking. So the way that I do it, I have the wireless link between the mount and the computer is extremely short, but that's because I'm remote desktoped into that computer. So the computer that I'm physically sitting at and interacting with and live streaming from is not the computer that's out there. It's just remote desktoped into it to give me control of it as if I were out there.
How do you deal with temperature for that computer?
It should be okay.
I know you said that you had it stripped down to, no keyboard and no, it's basically just a computer board.
Well, it's a. Let me see if I can. It's like an Intel NUC, so it's a fully built and packaged product. It just does not include a keyboard and mouse. It's kind of like a desktop computer. It's just teeny tiny. So it would be the same if I used a desktop, but I just didn't plug a mouse or keyboard or monitor into it, and I'm only addressing it through the network.
Could you use a Raspberry Pi to do the same thing?
I think so. I think there's stellar. There are some astronomy Raspberry Pi images meant to help people to do that. But I like SharpCap doesn't run on Linux, and currently there's no real live stacking program that runs, unfortunately. But this is that galaxy, and there's definitely a bright star there.
Oh yeah, definitely.
Can't tell if it's the supernova until we get a reference image. But this website also provides, usually it also provides the discovery image. So if we, this is the one that we're looking at in this galaxy.
Is that Rochester?
Yep, so it's rochesterastronomy.org/supernova.html. And if we click on the supernova that we're interested in, it'll take us to a big long list. And you got to be careful reading through and selecting to pick the correct image. But this is the supernova that we're looking at. And
Yeah, I think so.
we can look at other people's discovery images. Oop.
7722, right?
Yep, 7722. And that's a good point. We could also just look at Cartesiel and then look at the data for that thing. And right now my view is flipped 180 degrees because we did a meridian flip. But there's no star present in that reference image in Cartesiel. And the images that are built into Cartesiel are pretty old, so they're a decent, stable reference. So that point of light is definitely a supernova currently going off, or depending how far away this galaxy is, you know, a couple tens or hundreds of million years ago.
Well, we can find out. That's pretty cool. I think that's the first supernova I've ever seen live. Just made my night.
They're a lot of fun to hunt down, but a lot of times there just aren't any up, so it was a good thing we checked. Or if you look at the list, a lot of them they don't have an associated galaxy.
Yeah.
They're just unknown. They detected a new point of light, but either the galaxy is so small and obscure that it's not cataloged, or they don't know that a galaxy is there because it's too dim, but the supernova is bright enough to announce its presence. It's crazy.
Yeah, that's definitely it. I'm looking at images from Telescopus.
Yep, that's a really nice, handy website. But yeah, this is another discovery image, and it definitely looks like it. You just got to remember that my view is 180 degrees flipped, so you can see that star is above the galaxy. In my view, that star is below the galaxy.
Which makes sense. No, you wouldn't want to be too near that.
Yeah.
Interesting. It looks like an elliptical galaxy, or it's definitely an irregular.
It looks like it has a dust lane in it, though. A dark divide, some structure.
Right. I was looking at one of the pictures here that leads me to believe that it's very far away. You can there's about 3 other galaxies around it. They would be in your photo. They would be to the upper left. There's about 3 other small, at least 3 other galaxies, and then there's a bunch of them way behind, teeny little things. Cool. We've got to see a supernova.
Oh yeah, there's a ton of them out there. Look at it. All these little fuzzy patches.
I think the cool thing to do would be to come back a few nights later and see.
Yeah. If I had the proper software in place and the knowledge of how to do it, it should be possible for amateurs to take a light curve on it too. And you could determine the type of supernova by how, you know, the light falls off. Or if we had the R-spect diffraction grading, you could actually take a spectra on the supernova, which would be really cool. But it has tons of background galaxies. It's a really nice field.
Yeah, if you look in the at some of the pictures there, there's some edge-on galaxies. Actually, I see if you can kind of see a few of them there. Yeah. Yep, you got me sold on this now, man. This is the way to look at stuff.
I think it's a lot of fun. You get to use the raw power of the imaging camera, but for pure fun, you know, just 80% of the power for 20% of the effort. It's a fair trade.
Well, what I would want to do with it is a little bit of both, where I'd want to do some more serious, like, photography, where I'm actually trying to, you know, get more stacked images, and but to be able to, like, do what you're doing, which is to show people. Yeah, you see, there's an edge on right there, and if you go zoom, you see almost right in the middle. Now off to your. Keep going over. Oh, now there's one there. Yeah, those are the ones. Yeah, that right there. Look at that. That's amazing. I just think that it's the coolest thing to be able to show people, you know, live.
Yeah, especially in general, I think it's really neat to be able to do, but especially in COVID times where we can't do much outreach.
Exactly. Yeah, I was talking to my friend about that the other night while we were watching your. Yeah, there's another one right there, and there's actually one even further over to the left, I think. There's one near that spiral. Yeah, there's probably about at least 4 or 5.
A dozen of them somewhere in there. Yeah.
Yep. But to do this, if you planned a night where you said, okay, you could do like a school outreach on Zoom.
Yeah.
And where if you planned a night and you said, okay, you would have to say, well, these are the objects that I want to look at, have information about them, you know, and you could do it.
It'd be nice to, like, curate a guided tour and do, like, stellar evolution and show a dark nebula followed by a very young cluster in a reflection nebula, you know, stars just born, and then go through an open cluster where it's cleared away the gas and dust, and then look at a couple different spectral types of stars, and then you could look at planetary nebulas of red giants later in life, and then look at supernova remnants, and if you're lucky, maybe a supernova that night, and just see, like, the entire lifespan of a star through example. I think that'd be really neat.
Think about it. If you got, I mean, there's so many people in our club, for instance, who are you know, we have experts in almost everything. You could actually, you know,
like
plan
co-hosts.
nights.
Yeah, it'd be fun to have, like, a guest observer that
and they could
go through their list. Because I can run the machine. I don't have the knowledge behind the objects, but I can slide the sliders and push the buttons.
Well, right. That's what so you would invite an expert for the night to talk about, maybe you'd have a galactic expert, and they would sit there and say, you know, you'd obviously have to talk to them ahead of time and say, well, this is my field of view. So these are, you know, they would know where you could go look. And then they could say, okay, go over and let's go look at that supernova and let's explain, you know, if you're interested, I'd be interested in talking to you about possibly doing something like that, where we could coordinate, observing nights where you could invite a school, or it's kind of a way of doing outreach during a pandemic.
Yeah, I would love to. I would really love to do that.
I think Richard has the connections with a lot of the schools where he could probably call up an astronomy teacher or a science teacher and say, hey, how about Thursday night at 9 o'clock? You gather your students together and, you make it maybe a half an hour to an hour, depending on what people, what level you had.
Mm-hmm.
Obviously, if it's really young kids, you would want to, but for high school kids, this could be really eye-opening.
Yeah.
I'd be interested in helping with that if anybody else would, I don't know whether there's other people in the club that do the observing, or the what does EEA stand for?
It's
EAA.
a weird, it comes from Cloudy Nights, the forum. That's just the sub-form that this happened to fit in. It's called Electronically Assisted Astronomy.
Okay.
It's not very descript. I would prefer camera-assisted observing. But
well, we could start a new thing.
Yeah. The public doesn't need to know about weird legacy terminology from some forum.
Be the legacy.
Yeah.
You create your own legacy. Somebody had to start EAA, and like you said, on cloudy nights, that's what they did.
But there are a couple club members that are starting to do it.
I definitely would like to get to this point. It's going to take me a little bit longer because I'm going to have to sell some stuff to buy some other stuff.
Yeah.
I have the basic stuff to do it.
Yeah, I think the Sony cameras are pretty good. They've got very nice sensors in there. It's just the software side, if you can get it to talk. And I know SharpCap has a under cameras, at least for the Pro version, there's a folder monitor camera. So if you could set up any other program that can control your camera and just dump the pictures into a folder, then SharpCap can pick those pictures up and live stack them right on the fly. And you'll end up with a folder full of pictures that you can modify later.
Well, remember that I'm Mac and not...
oh, yeah. ASI should be able to... I don't know if ASI can do that.
Well, what I'm trying to do is, since I have the ASI Pro, that's my next goal, is to figure out how I can do. I know I can do what you're doing with that. It's a matter, can I coordinate it with the carte de ciel, or do I have to do that? I mean, obviously you can track with the ASI Pro, but I don't think it's super sophisticated. So
did I show you the AS Air Live last stream?
Yes, you did.
I mean, it's a little simpler than SharpCap as far as functionality, but the fundamental basics are all there, where you have the live stacking, the alignment, the histogram stretch, and the dark frame and flat frame correction. It's just a little more crude on like folder file management. That's all up to you. You have to create the folder systems. So like SharpCap is kind of nice because it automatically organizes the folders and files and things, but that's just ease of use. It's not super critical.
Well, I have two Windows laptops. I'm not sure whether either of them are powerful enough to
How old are they?
Maybe 3 years old.
I think they should be good. The
really?
The little miniature computer that I'm using, it has a very low power processor that sort of, its lineage is from the Pentium and Celeron chipset. It's a very old quad core, and my previous computer just had a dual core, and that was enough to live stack. So this is only like I think a 2.2 gigahertz quad core with 8 gigabytes of RAM, I think. And previously I'd used 4 gigabytes of RAM. The first computer I live stacked on was a cheap Windows 10 tablet knockoff, and that had a Z8350 processor, which is just a dual core and only 4 gigabytes of RAM, and that live stacked just fine. So you might be able to run on the Windows laptop. And then what I did on this computer, you can probably see the watermark right here, is I went and upgraded to Windows 10 Pro without a Windows 10 Pro key. And the only downside is it puts this watermark on there saying, hey, you should buy an actual key. And the other downside is that they don't let you use a desktop background, and the only choice is black. But that's what I would do anyway for an astronomy computer, so it makes no difference to me. So it's been working out great. And with Windows 10 Pro, you get access to remote desktop, and then you can remote in over network. And I believe there's a client for Mac. So from a Mac computer, you can remote into a Windows computer. So like right now, that whole computer is just a window running within my real computer. So I think you should be able to do a similar thing on a Mac with a Windows computer out at the telescope.
Well, that's what my friend out in Indiana is a lot more. He remote desktops using
Like
a Windows
TeamView
and an
or-
Apple computer.
Oh, okay.
So,
Just familiar with it.
yeah. So I kind of hate putting a big laptop out in the wind
Yeah.
in the cold, though. I'm
Although
not
if
sure how I
they
would make that work. I
they
guess I could
self-heat.
put it-
Usually they draw like 30 watts, 40 watts. So as long as they're covered, they generate enough heat usually. The only thing to worry about is the battery. If you're running on battery, the cold really saps the battery chemistry. Runs
Yes,
out pretty
absolutely.
quickly.
I know all about that.
Oh yeah, your professional camera, you know.
Well,
But,
it's which battery gets colder first, the computer or me?
Yeah. But with a remote desktop, hopefully you don't have to
I watch
worry
the
too
Matrix.
much.
That's all we are is batteries, right?
Oh, looks like a pretty good streak of galaxies in here.
Oh wow.
Looking for anyone that... A lot of these are elliptical, so there's not a lot of detail on them. But usually I'll just click around, and that one looks interesting. So we'll go to and see what's there. So that was NGC 536.
So I might be selling my 224 to Sal.
Yeah, you could definitely use it. The 224 is a really nice sensor. It's just very small. That's the only thing. So it works great for planetary. But the incredible thing about it is that it has a read noise less than 1 electron. So it can, for deep sky, it can take incredibly short exposures, like these 4 to 8 second exposures. I started out with a 224 in that little telescope.
Yeah, I remember you say that.
I was offering Sal my 224, but he on a loan, so he's just seeing what's available. He hadn't accepted an offer yet.
Well, they're so back ordered that you know, and I'm giving him a decent price. So
Yeah.
it doesn't come with the original box, and you know, it's got. I'll try to find the cables, and I think it came with the wide field lens.
Mm-hmm.
I'm pretty sure I still have that. So you basically get it. Yeah, I'm trying to, like I said, regroup.
So the 8-inch Newtonian will be a lot faster. You'll be able to use much shorter exposures, and it'll be a little more forgiving on the sampling because it'll have a shorter focal length, so it won't have as much magnification, which are both great and handy. The only downside to the Newtonians is the column. They're bigger than an RC, but also the collimation is very touchy because it's so fast. So the getting
that didn't seem to be too much of a. I mean, you tell me. It seemed like it was a moderately easy process.
I think it is. The once you get the hang of it, it only takes 2 or 3 minutes to do, and I do it every single time I set up, so I know that the telescope is at maximum performance, perfectly tuned, ready to go, which is nice.
Right.
And with the right tools, it's pretty easy. I use online. Everyone recommends like $200 or $300 fancy collimation tools, but I just use a $20 laser tool and a Barlow, another $15 Barlow, and the combination of the two make it super easy and pretty accurate.
So when you do the laser, do you shine it at the wall and do it that way?
So there's a special collimation tool,
right,
that has basically it replaces the eyepiece, and it has a laser that's collinear and centered onto the cylindrical axis of the eyepiece. So that fires down, hits the secondary, goes down to the primary, and bounces back off the primary, off the secondary, back into the laser. So when you turn the laser on, it'll go off the secondary, land on the primary, and usually the primary has a little paper ring.
Yep.
And all you do is you adjust the tip and tilt adjustment on the secondary, and you aim that laser so that it lands in the center of that paper circle. And that's all you have to do for the secondary. And now you go to the back of the telescope, to the primary, and you adjust the tip and tilt there so that the laser enters the same way it came out. So the laser tool has like a window on the side with a 45-degree plate that usually has like crosshairs and circles, and you can see where the dot lands on that little window. So while you adjust the primary bolts, you can guide it back to center. So once you center it up on the secondary and the primary, you're done. Some people get confused with the 3-bolt adjustment, because instead of like left, right, up, down, the 3 bolts adjust at equilateral triangle, sort of 120 degrees. It's not orthogonal, but
right.
If you only adjust 2 of them, you can make do.
Yeah, I own a 4-inch, which is in bad shape right now, but just needs to be cleaned up. But once we get up and running again, I can maybe bring it to the club, and if somebody wants to clean it up, and I might even donate it as one of the school. Oh, look at that! You've got
some faint little wings coming off of it
galaxies. Too. Maybe that's one off to the very left of the photo. That might be a globular cluster over to the left.
I think it's an elliptical galaxy.
Or not a globular, elliptical, yeah.
We're starting to see some surface detail on this one, and the number was NGC 536. But it also has some very faint arms that just kind of fade out.
So on your chart, where are you seeing the galaxies that show? Oh, I see. They show up in red there. Okay.
Mm-hmm. And there's all different display modes. So I usually use line mode. It's just
Under
a preference.
Yeah, line and grid.
If you go to setup, display, you can change all sorts of stuff, but star display, there's line mode, photographic, parametric, and then there's a lot of settings. It took me, a couple days of poking and prodding and experimenting and like multiple times out to figure out what I like, what I don't like, and what I need to change to get it. It took a while to get used to cart to seal. I like it. I just wish it had more information on the objects.
Well, the other program that I have is, what's the one I just downloaded or I upgraded the other night? Hang on. I will find it here in a moment. I always love it when when Astronomy Magazine tells me what their great products of the year are. And I look at this ArtTech 200 Pro f2.8, and I'm looking at that. I'm going, oh, that looks really nice.
The Sharp Star thing.
I think so. And then I click on it, and it says like
$3,000.
Oh, yeah, 4,000. Nope.
Yeah.
Next place.
I'm hoping to approximate that. So the F4 Newtonians are really nice and fast, but there's two companies out there that make and sell a 0.73 reducer combination Coma corrector.
Yep.
So that's the other thing with the Newtonians is they absolutely need a Coma corrector.
Yeah.
So this is a micro four thirds sensor, and with a Coma corrector, the stars are pretty good in the corners. A full frame so I'm using a Coma corrector and the stars are good. Without a Coma corrector, the stars are very chromatic, and only the very, very center is okay.
That's the problem with my refractor. It's the same problem.
Usually they need like a field flattener.
Yep.
But so you'd have to factor in a Coma corrector in the cost of the Newtonian. It would be absolutely mandatory for a full frame camera. And there might be more vignetting. So like we saw how much vignetting I had when I turned off my flat frame, and that was with a micro four thirds. So a full frame would probably have even more vignetting, to the point where you may even have to crop a little bit. It depends on the Coma corrector and the secondary mirror size, though.
I think I would end up cropping anyway. But
take a look at the heart. So this will be interesting.
I've been trying to find the Heart Nebula for the last, but now I was trying to find it without my guide or tracker. I was using a tracker, but I was using my manual one where, I have to go find the object myself.
Yeah.
No go-to.
So if we're looking, let me turn all the labels off.
Trust me, I know where it is.
Oh yeah, it's very, very faint. So even when you're on target, it can take a while before it shows up photographically. So like here it is in my view, and there's nothing there. There's just the central cluster. IC4.
Because it's pretty big, right?
It's huge, yeah. It's way too big for my telescope. I can only look at a small portion of it. Let me write down the number. IC1805. So I've got 8 seconds. I'm gonna start live stacking. Clear out the old one.
When you're live stacking, what's your maximum? What your maximum time length that you will go?
It's unlimited. For me,
No, but
usually I go like 20 minutes, especially if it's like a live stream like this with a good discussion, or if I'm at the clubhouse talking with people and we're talking about stuff. In the background, it'll run for 20 minutes or so. When I'm by myself, usually I'll hop around like
the actual exposure time.
Okay, so for me, it's usually 8 seconds. I very rarely go to 16 seconds. I don't see a ton of benefit in doing so. But for the live stack integration time, usually I go between maybe 2 minutes to 10 minutes, averaging around 5 minutes. And it depends on the object too.
All right, where did I put you here? Now you're gone. I can hear you, but I've been moving stuff around my screen, and now I can't find you. It's tough getting old. Oh, where? You're on one of these pages.
Usually the tab that's making noise will have a little speaker icon. Although if you have the video is muted for Discord so it doesn't echo, then it wouldn't. So it could be tricky.
Oh, no. I'm looking for where I put you on the YouTube. Yeah, I've been searching around for stuff, and I got like 2 screens going. So
yeah, same.
There you are. You're back.
So right now this is looking. It's only catching the sort of
the cluster and a little bit of the middle.
Yeah, like the top crook of the heart, where the 2 lobes pinch in, and then down in this corner would be the point of the heart, but it's out of field of view.
All right, so we got to get ready for the conjuncture of Jupiter and Saturn, December the 21st, the first day of summer.
Nice. I'm gonna shift.
I drive people crazy when I say that, but I've always looked at it from the standpoint of the days start to get longer. So my feeling is that we've always gotten this wrong, that the first day of winter for me is June the 21st. It's just my backwards way of looking at the world. It's like if the days are getting longer, that means I'm going towards summer, which is a good thing. That's what well, not from stars, looking at stars, but from warmth.
Yeah, need light for video.
Yeah, and my friends say to me, "Don't tell us this anymore."
Hello, hi Corey.
Hey Venu, how's it going?
Good. I'm actually sitting out and looking at the Cygnus loop, different parts of it actually, and
nice. With the refractor or the Newtonian? Are you using the 72 millimeter or the 8-inch?
Yeah, I'm using the the wider one, so I just ordered
It's huge.
a Zivo to Nikon adapter, so I can use my
Nice.
Nikon.
I have one of those.
Okay.
Although I only have a really inexpensive kit lens that came with my Nikon camera, and I actually I bought a really nice lens, a Rokinon 85mm f1.4, but it arrived from Amazon. I bought it new, but Amazon sent me a used one that someone had opened, and when they returned it, they thoughtfully decided to keep the lens cap, so it was shipped with the lens element just pressing on the packaging, buffing around,
Whoa.
just ruined. So I sent it back and decided that I wouldn't try that again. So
So the
hopefully,
combination with the OPT Corp, that triad lens,
the filter.
the H alpha, H beta.
Oh, I bet that's
H2,
fantastic
that
on
is
the
amazing what I'm getting.
even through the smoke and haze.
Yeah, it is actually very sharp and clear. I think.
Nice. I only have a UHC filter, which is like a very, very wide version. It passes a lot of other stuff, so it doesn't have nearly as much contrast as the tri-band or dual band.
Anyway, the choices you recommended is exactly what I'm using. I'm not using. I mean, basically, I have also that 8-inch f4. But the only thing that did not work for me was even today I tried the reducer, the 0.5
The
reducer,
cheap reducer.
reducer,
Mhm.
and the stars are going. It's just
In the
kind
very
of
corners.
explosive kind of look, right? And that I just could not. I adjusted the distance between the reducer and the sensor. Nothing seems to work. So you mentioned that
Usually they're for smaller sensors or less reduction factor. But for the refractors, they make specialized reducers that they also reduce, but they also flatten the field so that they give fully corrected, very sharp stars across the whole field of view. But they don't reduce a ton. They only reduce by like 0.8 or 0.6 or 0.7, somewhere in there. But they're a lot more expensive than the cheaper 0.5 reducer, the generic one.
I see.
And the generic one's handy. It's very useful for small sensors and slow scopes, so it can do well taking like an f10 Cassegrain down to f5, but to try and take an f4 Newtonian to f2, it kind of explodes and gets out of hand.
Yeah. In fact, with the 0.5 reducer and this telescope, it actually should be able to pull in the entire Cygnus, which is like 3 degrees.
Wow.
Field of view, but
it's a little distorted.
I was hoping to get that today, but it did not.
Yeah.
You can also stitch these images, right? I can take parts of these images and stitch them. Right?
Yeah, so you can make like a panorama, or they call it a mosaic, where you sort of reposition and take stacks of all the different parts and then stitch it together into one giant super picture. You just have to be very careful.
Can I use a Photoshop kind of a thing?
I think so. I'm not too familiar. I use a free program called Hugin. It's a panorama stitcher. Hugin, Hugin.
Oh, okay.
I don't think it's really meant for astronomy or astrophotography. It's meant for terrestrial landscapes, but I've had luck using it. It's what I used for normal photography, and I just tried it once for astronomy. It seemed to work. But Photoshop might have better, more powerful tools, or some astronomy package might have better tools. The only thing to watch out for is you'll need a very good flat frame, because if you have any vignetting, when you try to tile the pictures together, the vignetting will be very apparent where the borders overlap and things change abruptly.
I just found another cool object to look at.
Where?
Well, it's a supernova 1572. I'm trying to see if it has an NGC. I just found the other program that I have, which I think I could use to control I'm pretty sure I can use to control my telescope, which is Starry Night, or Starry Night Pro, which is very similar to the French program that you have there.
Okay.
Okay, so the Supernova 1572, which I don't see the, trying to see if it has a NGC name. Historical supernova, circumpolar. So it's would be slightly down to the left between YCAS and Cassiopeia and CAF. Actually, if you go between, is it Shedar, YCAS and CAF, and you go in between that, it's out kind of where that V is. You go the opposite direction of the way the V's pointing. Unfortunately, it doesn't have. Doesn't have an NGC name. You might like this program. It does cost money, unfortunately, but it actually shows you the picture of the object as you go in on it.
I think I can turn them on only the very brightest objects in Cartesiel.
Yeah.
I have it turned off normally. They're only black and white pictures, but you can elect to show the pictures, but you have to install them. They don't come standard because they take up a couple 100 megabytes.
Yeah, unfortunately, it doesn't tell you. It's an interesting looking object, but it doesn't. I don't know whether Cartesiel tells you if you can look up a supernova 1572. But it's in Cassiopeia. Yeah, I'm pretty sure I can control my telescope with this program as well. So it would be very similar to what you're using. And it's Mac based, so.
I was gonna say there's a software by Celestron. I think Celestron plane wave integration or something, but it might be a Windows only thing.
Well, they also have Sky Portal, which runs on Mac.
Oh, okay. Is that the Wi-Fi link?
Yes.
Nice.
I have that as well, which is what I've been using. But I've got like I said, I have too much stuff. What I need to do is get one system to work. That's always been the goal of all of us, right? You want to get like what you're doing. You got a system to work.
Yeah, I've just been sort of slowly building and tinkering with it.
Yeah.
But most of it's been the same. There's my next version will be a little different. I'm hoping to get a hold of one of those coma correcting reducers. The only problem is they're extremely expensive new, but when they sell used, they sell for a lot less because they're extremely frustrating to use. They're very, very touchy. They're extremely dependent on collimation and tilt. So a lot of people will get them and get frustrated and sell them. So I'm hoping to come across one of those. But it would take the f4 Newtonian down to f2.8, which would be crazy.
That's not a hyperstar, is it?
No, the hyperstar is for the Schmidt Cassegrains. Yeah.
Yeah.
It's close, not quite. So the hyperstar gets to f2, but this gets to f2.8.
Are they? Oh, go ahead.
No, I was wondering what's the advantage if to combine the reducer with the corrector. Like having it separate kind of gives you more flexibility, isn't it?
If you were to put a reducer in front or behind of a coma corrector, it wouldn't fully correct. There would still be aberrations, like the simple 0.5x reducer. It's not corrected for anything. In fact, it usually introduces aberrations. Even under ideal circumstance, it usually introduces some spherical aberration and some field curvature. But there's a when they optically design the coma corrector reducer, it's designed to be corrected, so it corrects for coma, has nice sharp stars across a field of view, but it also reduces the scope and gains some speed. It's just they're not very common, and they're very niche, and they're very expensive. So I'm hoping to find a used one.
Explorer Scientific 2-inch HR coma corrector for Newtonians is $329.
Yeah, so that's just a standalone coma corrector.
Yep.
So it doesn't, well, that one in particular will increase the focal length by 15%. So it'll actually slow it down to maybe f4.4. But
So
I use a Skywatcher Quattro, which it doesn't affect the focal length, so it keeps it at f4, which is fast. Just at least for the live stacking, speed is king. To be able to collect as many photons as fast as possible to overwhelm the read noise in as short a time as possible. So for absolute raw power and speed, the fast scopes are nice. But for traditional long exposure astrophotography, it's as long as you're below like f7, it's usually okay, because you can substitute, lack of collection with just more duration.
So those are $300 as well.
The Quattro compared to the HR, yeah. I was originally looking at a Bader MPPC Mark II, which is like some of the more inexpensive coma correctors, but I guess they tested poorly. They introduced some spherical aberration, and they weren't as good as the Quattro. And the Quattro is not as good as the Teleview Parkour, but the Parkour costs like $500, and it's crazy expensive, and it's only like maybe 10% or 5% better. So there's no real point in doing that. And it also slows it down by 15%.
Here's a used one on eBay for $230 in excellent condition.
Nice. The Parkour or the Quattro?
You said you already have one. That's the Quattro.
Yeah. So I'm using a Quattro in mine, which is, it's also the same as it's a rebranded coma corrector from also known as a GPU aplanatic. And that one is also favorable. It tests well. That's a funny cluster. It's kind of squashed or stretched out. A little long.
I keep losing. I'm going back and forth at all these windows. And where'd you go again?
But my end goal is to use the reducing Coma corrector with the 12-inch f4, because the reducer reduces your focal length, so you don't have as much image scale. So when you zoom way in on distant galaxies, you lose a little bit of that resolution or magnification. Or
Now, is that a combination Coma corrector reducer?
yeah, and that's what makes it very expensive.
And who makes that?
So there's two companies. There's ASA, which is, I think,
Yep.
Austrian, something to do with Austrian astronomy supply, but they're like Swiss watch crazy expensive. And then there's a telescope service out of Germany. They make one. They both are 0.73. They're each about $800 to $900 though. But I've seen them go used for like 400.
It's like getting a hyperstar.
Yeah, yeah. But they're extremely touchy. They're extremely temperamental, as far as I can read, to the point where the deflection of the steel tube is too much. So like, if I'm looking at the east and I collimate the scope, and then I look to the west, just the elastic deflection in the steel tube is enough to throw the collimation off. So they're like nightmarishly frustrating. So people sell them off dirt cheap. Not dirt cheap, but more than half.
Oh, are you looking at the Bader Mark III?
I initially I looked into it, but they're not perfect. They introduce a little bit of spherical aberration. So you actually lose definition in the center of your field of view. So when you add it, you actually, your stars become a little fuzzier than before you added it. But the stars at the corner become sharper. So without it, the stars in the center are pinpoint sharp. The stars in the corners have coma, they're stretched out. But when you add it, the corner stars look better, but the center stars are impacted a little bit too. Whereas the Quattro corrector doesn't impact the stars too much, and it keeps it pretty sharp across the whole thing. I can send you a study. There's like some guy did a pretty intensive comparison, and it's handy for shopping.
You seem to be doing okay tonight anyway, so. But yeah, it would be nice to get it to 2.8.
Yeah, I want one, but they don't show up often. And f4 is fine. 8 seconds is plenty. Basically, if I were to get one, I would probably still use 8 seconds, but I would just use a lower gain, and it would give me a slightly higher dynamic range, maybe. But I would be able to go down to 4 seconds, and I'd have almost just the same brightness, the same signal.
You just got to ask yourself one question. Is that extra 4 seconds worth the price?
Well, that's half of the equation is in the shorter sub exposures, but the other part is the shorter integrations. So instead of looking at a galaxy for 20 minutes, I could get the same detail in 10, which is pretty attractive.
Okay, yeah, yep.
Which means I can look at more things per night, given the weather and the limited clear skies. But I don't know if I'll ever get one, but I'm happy at f4.
Any thoughts on solar? I was looking at the quark Coma for. I've never looked at the sun much, and I know that is one thing for sure that is around, which I'm looking at. I know prominences and are fun to see. Do we have anything at the clubhouse for our solar observation?
On the work party weekends, usually if it's a clear day, some members will bring their hydrogen alpha solar scopes and share views, and it's really, really cool to see.
I have a solar filter for both my still camera and one of my smaller scopes.
Is that H alpha filter?
Or white light?
It's white light, yes. I have both orange. One is orange and one is white, and I used it when I shot the
solar eclipse.
The eclipse, and it's the white light filter. I mean, they're not super expensive, and actually, to be honest with you, now's the time to get one because I bought mine right before the eclipse, and getting that filter was like next to impossible because everybody was going out and buying them.
Yeah.
So they're not super expensive to put on the front of any camera. The one thing about solar observing, especially with the DSLR, is I was doing a time lapse of the eclipse, so my camera was pointed at the sun a lot for a long time, and so it actually heats the chip up. So you have to be very careful about that. I have a funny picture of my camera that I was just using the one shot. I was just using a 400 millimeter lens with my DSLR and had a tracker, but I had a styrofoam plate the lens punched through a styrofoam plate to keep the heat off of the sun off the
body.
The body, because it was heating up the body so much the camera would stop working. So
Jeez.
But if you're just doing observing of the sun, it's cool. I mean, when the sun has activity on it,
especially the sunspots. So the
you need the dedicated H alpha. Filter. That's what I was referring to. It's about $1,200, I think, for the.
They're very expensive.
From Daystar. Yeah.
Oh, if you want to go that route, and if you want to do really like heavy detail, or the flares that are coming off the edge of the sun.
Prominences and flares and the chromosphere that is there. That was what I was interested in. And there were a couple of choices, right? Like there is a Coronado personal solar telescope, which is like
so there's like the optical dedicated Etalon filters that are very crazy expensive.
But I was recommended this chromosphere, quark.
The electronic device.
And it actually gives you both prominences and chromosphere, and also apparently you can see these plagues and there are 7 or 8 categories of phenomena that happen on the planet, which is categorized, and several of them that you can see.
The H alpha scopes are really, really cool. It's just they're very expensive. And the white light will show you a lot of detail around the sunspots when they come back.
It works with the 72 ED because they don't work with they do not work with SCTs, or they do not work with the
definitely. The secondary mirror would probably get too hot, especially on a fast Newtonian. Like that f4 Newtonian would be very dangerous to do any solar work with.
So for the 72 ED, I was thinking, if I'm willing to spend the money, that would be a quark.
Yeah, I would definitely try to get a view through one of the club member scopes whenever we open up and do work parties again. just to set expectations. I read about the quark thing, and it looks really cool. They seem a little expensive, but I'm not sure what on cloudy nights solar observing area, they seem to have like a mixed opinion where they're extremely versatile, where they let you turn almost any scope into a solar scope, but there seem to be some limitations. I never learned, too much about it,
Yeah.
but
I think once you go beyond that, the rest of the things are like $2,000 and $3,000.
yeah, it gets very expensive in the large diameter etalons. It looks like the Pleiades is coming up, clearing the trees. I'm going to frame it a little off center. I think I want to try and get, I can't quite fit the whole thing, but I want to try and get some of this nebulosity off of this star here. Usually I'd frame the stars, but I end up clipping that little bit of nebula. So I'm going to sacrifice some of the stars to see if I can get that nebula. Probably not ideal looking this far down, just because we're looking through a lot more smoke and horizon and light pollution, all kind of compounding, but we'll see what the camera will do. And before we do that, I'm just going to save the snapshot of M76. And I can clear it out. M45. And again, this is 180 degrees flipped compared to the star chart. So we'll start live stacking, clear out the old one. And we'll see how that goes. Definitely a lot brighter than the previous area. You can tell just from how the histogram is shifted over to the right compared to where we had it adjusted last time. Curtis in the chat. Sorry, I didn't see the message earlier. If you're a member of AtMob, I think I sent an email out to the Discuss with the Discord information on there. It's the club's Discord, so if you're not a member, unfortunately, you won't be able to get on the voice chat. You can definitely see some of the nebulosity around the Pleiades. Might try to adjust the color balance, see if we can get it. That looks more normal.
Well, it's a good thing you're here tonight, Corey, because I just went outside to look up at the sky, and I could be on Venus right now. It is totally fogged in here. It's interesting how that works on when you live on the coast.
Yeah, yeah. That's the only thing with the Halibut Point. There's a fantastic astronomy club out there, the Gloucester Area Astronomy Club. It's just the weather is so volatile as far as the forecast for clouds, where the forecast could say it'll be perfectly clear, but they'll have like a fog bank come in.
Who's the gentleman that has the 35-inch telescope in Marblehead?
Mario Mota.
Yeah, Mario. Yeah.
I think the 32-inch out of Gloucester, but it's all amateur made. He ground the mirror himself.
That's impressive.
It's incredible. Yeah, and he has it in a huge observatory attached to his house, which is awesome.
That's also impressive. Next life.
I think there's a couple of YouTube videos. I think someone recorded a talk he gave summarizing the build, and you can see like a slideshow of the build process. And there's one where it shows the concrete pier that goes through the center of the observatory where the telescope is mounted, and it's completely isolated from the building so that wind vibrations don't transfer to the mount. But this massive concrete monolith went up before the house, so the plot looked pretty strange for a while.
The Pleiades are up.
Yeah, so we've got them in the scope now.
They must just be coming over the horizon.
Maybe, let's see, as altitude is 16 degrees.
Yeah, so it's still fairly low.
Yeah.
This is in one of the notches that I have to the east. So usually my horizon's around 40 degrees, but I've got this dip to the east.
I'm curious, with the 8-inch, can you show me your widest shot of the...
Sure.
Pleiades?
So right now I'm not centered on the Pleiades, or
Yeah.
I'm just nearly centered, but I'm offset so that I can get this clump of reflecting gas and dust. So I can just about fit them all.
We're able to see that.
But I've seen some wide field images that show the really wispy faint nebulosity, and it extends far beyond what I'm framing here.
What is it that you're looking at right now?
This is the Pleiades M45. Right now it's upside down.
There's only 7 main sisters. There's actually it's a big family. There's a lot more than 7 sisters in there.
Yeah.
Now you're starting to pull out some of the.
You can really see the kind of wispiness to it.
That's a tough. Yeah, they're tough to shoot to get the nebula to show up because of the stars are so bright.
Yeah, they want to kind of flare and take over.
I've been thinking of writing a science fiction book based on somebody who grew up on a cloud planet, and what would their perception of the universe be? They wouldn't have a universe other than because they'd never see beyond the cloud.
Yeah.
I think Star Trek might have delved into that. I'm sure there's some science fiction writer that's delved into that as to what happens when they finally figure out that there's something beyond the clouds. Yeah, the last talk, the AtMob talk, was pretty good when it came to, the whole idea of life beyond our planet and how big the universe really is.
Yeah, there's got to be life out there.
Oh,
I don't think we'll ever make any contact with any, but
no.
But there's, millions and billions of stars per galaxy and just billions of galaxies and all the exoplanets that we found. And our detection methods are extremely limited, and they can only detect a tiny percentage of the possible planets. They have to be almost perfectly in plane with us and have, the right characteristics to have the right types of orbits where we detect the light curve, or to be aligned well enough to get a radial velocity.
Was it the science fiction book, The Three-Body Problem, where the way that this one star race attacked another planet was by sending a digital signal that basically, once you opened it, it was like a malware. So that's how they would eventually take over your planet, was that they would send this malware to these up and coming planets that, were looking for intelligent life. You'd open the packet and that would be like, oh, that's not a good thing to do. Might have been the Three-Body Problem.
Yeah, that one looks nice. 925.
Yeah, that's looking pretty. It's interesting that we found that other little, that was 7129 was the other little Pleiades that we found.
Oh yeah, the little mini one with a little bit of reflection in Cephus.
Yes, Cephus, yes.
Cepheus, or I'm not very good with the pronunciations.
I'm going to head out because I have to paint another deck tomorrow. This house has great views and it has big giant decks, and they occasionally need to be redone. And
at least the weather's looking nice and warm.
Oh, it's been perfect. It's been perfect. Although I might have to stop my mom tomorrow because I think it's going to be too misty for painting tomorrow morning.
Yeah.
So, well, thank you again for the tour, and I'm learning so much. And I would seriously like to, if you're interested in potentially, putting some, kind of figuring out Star Party for schools.
I would love to. Yeah. And the great thing is it wouldn't even have to be one school. It could be,
Well, exactly.
3 schools
Right.
or 4,
You could do multiple schools
all at the same time.
I would. The way to do it would be to set up like a program, and you could either coordinate with the school with the teachers, or we get one of the members who's an expert on specific things to talk about, even like the Pleiades. Well, this is something that you can look at through binoculars.
Yeah, and you've got the wide field to show. You'd even see it there.
Explain what the stars are and the fact that most of these stars are close together, I think, right?
Yeah, they're formed together in a cluster, moving together through space on similar trajectories.
Right. And you could talk about the fact that the sun might have been in a group like this at one point. They do philosophize that. There is some evidence that we were part of a cluster like this at one point. So anyway, yeah, maybe we could talk to Richard about it and see whether we could put something together.
Yeah. I would really enjoy doing that.
Yeah, thank you for the Discord link, and hope to do this again with you soon.
Thanks. Hopefully it stays clear. We'll see. We'll punch through some moonlight.
At this, yeah, we're right. Yeah. Well, the fact that you're able to get this type of imaging on such a hazy night, I mean, the smoke is definitely out there, because I took a picture of the sun again tonight, and it was, just an orange ball again. So it's the smoke is back.
Hmm.
All right, have a good night.
You too. Have a good one.
And Venu, I'm Mark. Nice to meet you online.
Nice to meet you, Mark. I'm sitting here looking at the Cygnus loop. I'm trying to do a panorama here.
There you go. All right, well, have a good night.
Good night then. Yeah. Thanks.
How's it going, Venu?
I actually that filter is fun. It's actually giving me the nice, pretty looking pictures. Let me call it that way. So
Yeah.
nothing scientific about it here. It's more.
But it gives you phenomenal signal to noise, cutting out all the light in the sky.
So I don't have enough patience, so I'm just taking 5 minutes exposure on each of those regions around the Cygnus loop and trying to see if I can put them together. Meanwhile, for October, or I said September, the challenge object is what? Whale Nebula, right? Yeah.
I think so, for September. Which is the Cygnus loop, right?
Yeah, which is I guess any one of the Cygnus loops, right? Objects in this. There are about 4 or 5 major objects in the Cygnus loop, right?
Yeah, it's kind of broken into pieces.
It's basically an exploded star, right?
Yeah, it's a supernova remnant. So after the sort of materials are flung off into space, and they kind of shock heat as they collide with the thin gas out there. The veil always looks so cool with the color cameras, to see that sort of lacy. It always reminds me of old 3D film with the 2 color lenses.
I think I have. I thought I would just expand on what I have, but between the equipments I have, it seems as if I can do enough for a lifetime.
Yeah, absolutely. The sky is unlocked.
As soon as I got that triad filter, that made a lot of difference for my views into the nebulas.
Yeah, especially the emission nebulas.
Yeah, emission nebulas. Yeah. And I would love to get that. One of my interests is to get that quark thing. I think that's the only price range I'm willing to
Yeah,
spend.
that's. I'm in a similar boat. I can't afford it, but if I really wanted to get into solar imaging, I think that would be the way. It seems interesting.
Yeah, indeed. Every day it is. I mean, there is not the sky in the night, maybe a star in the day.
Yeah, I mean, it would be really cool to see any one of these stars half as close as we are to our sun. So we'd take advantage of it. It's right there for the observing. Same thing with the moon. A lot of people hate the moon, but if Mars were as big in the sky as the moon, for a night everyone would lose their mind just to be able to see it in that clear detail. There's
Is that a fireworks galaxy that you have on the screen, or is that?
This is M33 Triangulum.
Oh, it's a triangular. Okay.
Yeah.
I think this has got the trio of our Milky Way, Andromeda, and the triangulum, right? These are.
Yeah, the sort of closest neighbors. But I've been thinking about getting into trying to do more planetary lucky imaging at high frame rate. Like I want to try and take pictures of Mars and pictures of craters on the moon. Just because I really like the moon. There's so much.
But then you would like to get a little bit deeper focal length, right? If you are looking at specific areas.
Yeah. So what I end up using is a 5x Barlow. At least with the camera, that will give the optimal sampling for lucky imaging.
Oh, okay.
It's not ideal. I think most people.
What is it?
So the atmosphere is usually the limiting factor. Usually the seeing blurs everything out to like an arc second. So there's no real point in zooming in beyond an arc second pixel size for sampling. But there's a trick where if you take really, really short exposures, you can actually kind of freeze the motion of the seeing, and most of the time it'll be blurry. But during those, if you've ever looked at the moon visually on a really sort of bad seeing night, it's kind of swirling and boiling, but every now and then it just kind of pops into clarity for just a millisecond or two, and then roils and broils. So with lucky imaging, you just record at really, really high frame rates, and you hope to catch those moments of clarity, and then you take that video that hopefully contains a couple of those moments of clarity, and you run it through software, and that software analyzes every single frame, evaluates them for sharpness, and then it scores them, and then you can weed out all the blurry stuff and only take like the top 10%, the super sharp, perfect focus frames. And then there's some stacking programs where it even though it's sharp, it's still kind of distorted from the seeing, and it can combine all the hundreds or thousands of frames together into one really high quality frame, and then you can sharpen that frame with wavelets, and it's incredible the amount of detail people can pull out. But it's like completely different than deep sky long exposure, or even the short exposure live stacking. Most of the time people use Schmidt-Cassegrains with like a 2x Barlow.
Yeah, I see. So I can get a 5x Barlow, right? That would help even in the Mars view and all of them.
Yeah, for the camera it would help. For the eyepiece, I think just a 2x Barlow would be good enough.
I want to get it for the 5x Barlow for the 1 point. So you said a 2-inch or a 1.25-inch?
So the
5x.
so the 5x Barlow would only really be useful for the camera. For visual with an eyepiece, a 2x Barlow would probably be better.
SV Bonnie's Barlow lens, I should be happy with it, right?
I'm not sure. So that's what I bought. I have that one. And I've only used it once, and it seemed to have a little bit of haze, but I'm not sure if it was the smoke or the lens. So I can't really evaluate it until the smoke is gone. But it was only like $15, and it helped. I don't think I have. Let me see. I got. I'll show you the picture I got. It'll take me a little while to dig it up. But I was surprised by the amount of detail. I was definitely got $15 worth out of it.
Yeah, I was thinking, I buy no $15 we cannot go wrong with it.
Yeah.
Instead of spending hundreds of dollars.
So it's not nearly as good as other pictures of Mars, but it's not a bad first attempt. Like you can definitely see different areas and structures.
Polar cap and stuff, huh?
Yeah. For whatever reason, mine came out, the colors weren't great, and I didn't get a white polar cap. But I still have a lot to learn. This is just like a first attempt at it. But there are more expensive 5x Barlows, but I wanted to at least try the cheaper one first. There's some like $130 ones, and then there's the Teleview crazy expensive $300 one. And it took some messing around to get it to focus too, because I think Barlows tend to push the focus out. So I had to like use different combinations of extension tubes, similar to using a focal reducer where you have to shift the focus in, but you figure out how to shift it out.
Yeah, OPT Corp has got a 5x APO Barlow. What's an APO Barlow? APO Barlow is a little bit.
So it probably has no chromatic aberration, multiple elements.
I should be able to use that. It's $40. Yeah, I could probably consider that.
If you intend to do visual, then I think a 2x Barlow would be good enough. I don't know.
That I have. I think
okay,
I have
yeah.
2x one. I'm not too honestly, I'm not too fascinated with visual in my life because not all that I want to see can be seen visually anyway. Many people don't seem to like the fact that looking at I know when I look at it, I see a white sponge somewhere. I don't see. I have more fun looking at the screen, right?
Yeah, I enjoy the electronic assisted for DSO.
Yeah.
I think
I spoke to a couple of people of an established people of our. They don't like it. They want to see it and feel it, and they want to feel the photons coming into their eyes, I guess.
Yeah. I think my stance is it is fascinating that the photons have traveled, millions of years across the empty vacuum of space, but I'm not too concerned what happens in the last few milliseconds, as long as I get to see a direct and immediate evidence of their journey. And if the camera lets me do that easier with more detail. But I still like to do a visual for just the experience. Sometimes it's just relaxing. I don't do it with. I actually sold my 10-inch Dobsonian, and I never really used my 8-inch f4 visually. but with a smaller scope on a manual Alt-Az, it can be fun to just kind of surf around and look at the familiar showpiece objects. Mostly I just like the hunt with the paper star chart. Trying to find stuff is fun. It's okay if it's just a little blurry thing. It's still neat to look at. But for like critically examining something to try and extract as much detail as possible and to see as much of what's there as possible, then I like the live stacking.
Yeah.
And when it,
what you showed me with the SharpCap literally changed. I mean, I don't have to spend hours in post processing.
yeah,
I don't have the
just
time to do
use the camera as a tool.
Yeah.
It doesn't have to be perfect.
I think I have come almost a full round of circle. I'm doing just 5 or 6 minutes each, but I just wanted to get the full loop, and I'm going to stitch it together. And whatever mains I can do it. Should be fun. I've never done it before, so.
Nice. Are you for Discord? Are you using your computer or are you using your phone?
For Discord, I'm on both. I mean, in fact, I'm using the phone right now, and I have got it on my computer too. I can. Discord on the computer you can actually share, right?
Yeah. So you could stream your screen if you wanted to show.
Yeah, I can do that. Just bringing it up on the. Yeah. I can share my screen.
Yeah.
I've done that. Well, let me see.
So when you do that, it'll pop up as a live stream. There we go.
Let me know if you can see it.
It's loading in. I can see it. Is it okay if I show this on the YouTube stream? Nice. So is that a single frame or the stitched panorama?
What happened? It came and left? Or...
Yeah, it looked like it ended.
No, I don't know. I don't know what happened. It just was start. Yeah, I don't know how to restart it. I've taken about 10 or I'm using Karte du Cel. I'm going around. I'm using that to go around, and it seems to be doing what I'm capturing. What?
Oh yeah, I can see it. Oh, it looked like it ended again.
Oh, you know what? That happens every time I touch my phone.
Weird. Maybe it transfers control to the phone, but it can't stream, so it.
What is happening? I don't know if you can see it or not. No.
I don't see it.
Yeah, I can only connect one or the other. Yeah, funny. I can only join the voice on the phone or the stream on the.
Oh, that's weird.
So you know what? I could probably. So probably I can just disconnect from this on the. I can just stick with the. Yeah. I'm sure Mario is also doing something, and I usually he must have some incredible views.
Yeah, the amount of light that a 32-inch telescope can pull in a very short order of time is impressive.
There's a Facebook page, beginners astronomy for beginners or something. I'm a member of, and there's a guy who posted it with 50-inch Dobsonian and
5-0.
yeah, 50, and he's using it for astrophotography. Obviously, he can do it very fast.
Holy
and it is
cow.
something like F4 or something. It is very fast also. Must have spent a ton of money. He built it himself.
Wow. Even the mirror at that size?
I guess so.
Or was it a fuller, one of the hollow structure ones that are assembled? The sintered glass. You can see this dark cloud.
And obviously, for that kind of an aperture, you can do astrophotography even with a Dobsonian, right? You don't need an equatorial mount and so forth, I guess.
I think at f4 you could get short enough exposures. That's what I'm planning to. I have a 12-inch f4, but it's too big to mount on my equatorial mount. And I was considering getting a larger equatorial mount, but it was just too expensive or too much hassle to set up. So
How much does it weigh, the 12-inch one?
So that, yeah, it's big. It's very big. It's it weighs 57 pounds.
Oh, okay. So you need a really big mount.
Yeah, and the big mounts are tall. So in order to get it into the saddle and bolt it, you would have to lift that up over your shoulders, get it into the saddle, hold it there with one hand as you tighten the bolts, and that scared me away. Yeah. So I'm planning to build a Dobsonian mount for it that's motorized and tracking in alt azimuth.
Oh, okay.
And then because the live stacking aligns the frames and the exposures are only 8 seconds, that's short enough to avoid field rotation. So you can actually do live stacking from an alt azimuth mount with no problems.
Cool. Okay.
So that's what I'm hoping to do. So just sorry, Curtis, in the comments, it was a while before I checked back. So it's a Skywatcher 12-inch f4. I got I got a really good deal on it used. I guess for the New York Comic-Con, there was some commercial film crew that shot some commercial, and they needed a telescope, so they bought an actual 12-inch f4, and it ships with the tube and the mirror separately. So they unboxed the tube, shot the commercial, and then put it back in the box and sold it for half price. And the mirror was never touched, never opened, never unboxed. So essentially a brand new telescope for half the price. I couldn't pass it up. So I got it last maybe February, but I've just been sitting on it because I don't have a mount that can swing it. It's too heavy, it's too big, too bulky.
So make a Dobsonian out.
Yeah, so I have to make a Dobsonian for it. But with the Onstep, it should be possible to just make a motorized tracking Dob, and that should be good enough for EAA.
Yeah, so I thought, if I'm willing to spend maybe another few months, maybe 2 to 3 grand on a something which is a Dobsonian, which is like a 16-inch one, and in which case I could probably use that for a there is enough bucket of light that comes in, right? So I could still do for astrophotography with that.
You'd still probably need tracking, because the bigger, assuming the scope is f4,
yeah,
the exposure times don't change at all. f4 is f4. It doesn't matter if it's a little 12mm camera lens or if it's a 20-inch Dobsonian. The imaging speed remains the same if it's f4. It's just the image scale
doesn't decrease. So I see, because I'm pulling in more light, right? So I shouldn't be able to. If f4 larger aperture gives me more. Oh.
So the speed is mostly determined from the focal ratio.
Okay.
But the aperture, it'll be a little different on stellar objects, so stars, infinite points of light. Those will be much brighter in the larger aperture, for sure, absolutely. But for like diffuse objects, like most DSO, galaxies, and nebula, the brightness of the object will be the same at f4, and at a big lens or a small lens, if they're both f4, they'll be the same brightness. It'll just be a different size. It'll cover more pixels with the larger aperture f4 scope. Or you'll be zoomed way in, you'll have a smaller field of view.
So that just gives you greater clarity and more resolution, probably.
To a point, but up until you hit the atmospheric limit, which the 8-inch scope already hits. So the 8-inch scope is like maybe or with your 533 camera, you've got a 1 second arc second per pixel sampling. If you were to go to like a half an arc second or a quarter of an arc second, most of the nights you would be limited by seeing. The seeing would just smear everything around, and instead of a star being like 1 or 2 pixels, it'd be 4 or 8 pixels. Even though you'd be more zoomed into it, you wouldn't actually resolve anything more. So usually with the very big telescopes, what they end up doing is using very big pixels so that they kind of match each other. And with that combination, things get very fast and powerful. If you have a big fast telescope with big chunky pixels, they collect an enormous amount of light.
So the length of time, the exposure time doesn't change. That means it will.
Yeah. So the exposure time if you use the same camera and you're under the same sky, and you have the same focal ratio, the exposure time will remain the same.
Oh, that's a bummer.
And only the field of view changes with a bigger scope.
But then again, even if you have a bigger field of view, then obviously the pixels on your camera has to be large. I mean, there should be more, to be able to capture all that field of view. I mean, what's the purpose if you cannot?
Yeah, so if you have a very big scope and a small sensor, then the field of view is teeny tiny. So ideally with a big scope, you'd want a big sensor with big pixels, and those are very expensive. So I think 8" is like a sweet spot.
I think so. I think pretty much all of that, everything that we want to do seems to happen within that.
My 12"
I mean,
is kind of like a pipe dream. It's just an extreme for the sake of extremes.
And I can also lift it up and more easily put it up on.
Yeah, and you can fit it in a car.
Yes, indeed. And the only thing I thought I spent a little bit of money and bought it is that Ioptron's GM45. And
That's a really nice
mount.
mount.
It on the backpack of my backpack, and if I'm traveling, even I can put it on my backpack. It's 15 pounds.
Yeah, those mounts are really cool.
Unlike some of those Skywatchers mount, which is like 30 pounds, which does the same thing. But I bet that heavier mounts obviously have more stability, maybe. That's all I can see the difference. But it's cost me $1,000 more than the other one, which would have cost for the EQ6 and so forth.
If I could have any mount, it would probably be the EQ8 for the 12" pipe dream. But that'll never happen because those are way too. I think 110 pounds.
Oh, okay.
But that'll never happen because they're like $3,000, $5,000, something like that. Crazy expensive, and they're heavy. So not only is the telescope heavy, but the mount is heavy. Each piece of the mount is heavy. Like you can take the head off the tripod, but the head still weighs 75 pounds, and the tripod weighs 50 pounds, and then you need 50 pounds of counterweight. And then by the time you pile it in the car, you've moved 200 pounds of equipment from a second-story apartment down into the car, and then drive somewhere, and then unload it all, assemble it. It doesn't sound very attractive.
It is not, yeah. No. Unless you have a permanent observatory like.
Yeah, that'd be perfect. So I abandoned the equatorial idea for the 12" just because if I did, I don't think I'd ever actually use the thing. It'd be too much hassle. But I think with the Dob, just the base, plop the base down, plop the telescope in the base, all set, go. I think that would be worth the trade-off. Because the Alt-Az works for EAA, but it's not as ideal as equatorial. Like I've been looking at the Andromeda here for 11 minutes, and the edges are still pretty nice, but with the alt-azimuth, I'd probably have some triangles starting to clip as the field rotates a little bit, which is fine. It doesn't affect the center of the view. Usually that's where the interest is. It's a fair trade for ease of use and convenience.
By the way, when you are sharing your screen through YouTube, do you have a tool that?
Yeah, I can. This is probably going to get pretty weird, but I use OBS.
I also use OBS, yeah, but I was never successful in getting that. Is it display of the screen or display of the window that you choose?
So I do display capture, and I capture my big display, and I have a second display off to the side, and that's where I keep OBS and I keep the YouTube for monitoring chat.
So that works, huh? Okay.
Yeah.
I did download OBS. I was reading up as to how to do it, and Uh,
It's a little weird to this. Took a while to figure out. I had 2 or 3 streams where I just absolutely botched the audio and it just
oh,
ruined it. But took a little while to figure some stuff out. But once it's set, it's pretty solid and pretty reliable.
hmm, hmm. Wonder if the clouds are coming in now. No, it's not coming out.
It makes you wonder what the night sky would look like from a planet in there. Just all of those incredibly bright stars so close to each other.
Yeah. I actually went this last February. We went to when we had I took a week off, and then for a vacation we went to Arizona and pretty much planned, and we went to the Grand Canyon area, to the Page has also the Page, Arizona. I mean, the dark sky area.
That must have been incredible.
It was incredible, right? You can just look up and see pretty much a lot of things you are normally not see.
I remember Chris Elledge had a trip to the Grand Canyon and he took some DSLR photography of the Milky Way, and it was just crystal clear right down to the horizon almost. It was so cool. Whereas you try it around here, or even in like Maine, as you get down to the horizon, just all the cities in the distance, it starts to glow. But out in the desert, it just goes straight down. The other thing I'll be interested to see with the Alt-Az, with field rotation, the diffraction spikes will remain oriented to the camera and the telescope. But as the view rotates, the diffraction spikes will rotate across the live stack. So instead of being a sharp, crisp spike, it'll start to turn into like a German iron cross, which will be interesting.
The cloud may be there on the west. My images are
I usually check like 3 or 4 different forecasts, and they mostly seemed clear, but one of them had some clouds after midnight, so maybe that one was the one accurate report.
The western veil is seemingly messed up because it was coming up until now very well, then it started. If not for the SharpCap, I probably would not have gone into this.
Same. I have no interest in collecting hours of data all night long to not even look at them, and then to sit at a computer for hours a week later to process them into a single picture. It's not my cup of tea. But to just wield the power of a camera as an observational tool is awesome. To be able to pull this in no time at all, and then to have snapshots and pictures to share. And it makes it so much easier too. Like reading on the forums, the astrophotography forums, all the trouble that people go through to take really long exposures at.
Yeah,
it's just like, I don't want to do that.
120 hours.
I mean, the results are phenomenal. Absolutely, no denying it, but the effort is... I just love the detail in the dust lanes there. Look at all those dark nebula. I am curious with the 12-inch. It will, so right now my sampling is 1.2 arc second per pixel, because the 294 has a little bit bigger pixels than the 533. But with the 12-inch, it'll take the sampling to 0.8. So that'll take me to sort of the threshold where I'll be hitting the atmospheric limit more often. But on a good night, I wonder what it'll be able to show.
You want 1 pixel map to 1 pixel map to 1 second, right?
Usually that's like the general rule of thumb, because usually the seeing varies between like 3 arc seconds and 1 arc second. Sometimes it gets a little lower, but more often than not, it's like 1.5, 2 arc seconds, at least for us in Massachusetts. Different parts of the country are different, or different parts of the world for that matter. But if you had like what was that?
No, my area is that Vale area is clouded up, so I got to
Wow.
move out.
Where are you located?
I'm in Chelmsford.
Chelmsford. Okay. You said it was coming out of the west.
Yeah, it is looking towards the west. Yeah, pretty much exactly towards the west.
Let me take a look outside, because I'm west of Chelmsford. I'm out in Maynard. It's hard to tell sometimes with the camera. I can pull through. It is pretty murky out here. I can see the square of Pegasus. That's about it. Although the window has a limited view. Oh, 1 second. I think this is one of the longest stacks I've had on Andromeda.
So when I do Pleiades, I need to remove that filters, right? Otherwise, everything goes in.
Yeah, you'll lose the reflection nebula, because the reflections are broadband, whereas the nebula filter is only passing the very narrow emission spectra. So it's going to cut like 80% of the light from the faint reflection nebula.
this is the night time when you have not many bright stars to focus on.
Yeah, that'd be tricky.
When I pulled out the lens, when I removed the, I need to refocus after.
Yeah, I wonder what the night sky looks like from a planet in M110. You know, if they've got a face-on view of Andromeda that takes up almost half their sky. I think the Milky Way is impressive. Imagine what that would look like. Just the spiral arms just completely wrapping around the horizon. That'd be insane.
I think there's a lot of haziness out there.
Yeah, there's definitely smoke in the upper atmosphere. On Astrospheric Forecast, it has a layer for that. So this is us. Looks like it's not as bad as it could be. But around.
Looks
I've got some little dark patches on M110. Oh, I gotta go. The mount position. It's across the meridian. I gotta move away from there.
all right. Are you going to look at anything more?
I don't know. I'm just surfing around looking at random stuff.
Yeah.
Take a look at this one. I like this as a paper thin edge on NGC 891. But I probably won't go on for more than 30 minutes or an hour.
What you have right now is our friendly Andromeda.
Yep. But I'm heading toward NGC 891. I think they call it the Silver Sliver. Although I might have it confused with another one. But it's a really, really thin edge-on spiral galaxy. So we're looking like right on plane with it. So all of the dust lanes kind of stack up. Yeah, it looks like my mount hit the once it passes the meridian limit, it automatically disengages the tracking. I just gotta find the button for resume tracking. It's been a while. Oh, duh, there it is. Let's try that again. But sometimes it's fun to just use the 2-second exposures with just the simple display stretch. Even with just that, a lot of times you can see more than you can see visually. Although, it's very noisy. But I think it could be fun for outreach. I don't know how well people will connect with live stacking. To say, yeah, it's really live, but it's a built image and it's stacking. Oh, you're making it up. It's not real. Yeah. So we're going to bump it up to 8 seconds. Go into live stack. I'm pretty sure I saved that. But you can see it has a really high contrast line going right down the middle. And that's just all the gas and dust blocking the light.
Which object is that?
This is NGC 891.
NGC 891?
Correct.
Well, it's pretty much up at the meridian.
It's getting there. Yeah. This is where I backed off to. I was watching Andromeda, but it went well over the meridian. I think I have my mount set up to do 7 degrees over. But I lost track of time. That one looks pretty good. I wonder if those two are interacting. NGC 672.
It's a pretty nice looking galaxy.
Yeah. I imagine it's pretty good looking visually too, because that would provide such a high contrast line. Part of the reason I'd like to make the 12-inch into a motorized Dobsonian is that I could use it visually. That's part of the reason I sold the 10-inch Dob, was to physically make room for the 12-inch, just because I'm running out of room in the living room. be curious to see what can be seen visually. And it looked like there was yeah, a bunch of distant background galaxies off to the corner. There's a nice little edge on here, another edge on. Looks like a barred spiral. Perseus is there's a fantastic galaxy cluster in Perseus. You can play around with the enhancements in SharpCap. See if the unsharp mask. Usually I end up overdoing it. But it's fun to mess around.
There's a bunch of galaxies next to NGC 891, right?
Yeah, it looks like a tight grouping, I think, to the southwest. My view's flipped.
So does that mean it may be one of those? I mean, there are a bunch of galaxy groups that we group them, right? That's how we catalog the universe, right? In terms of galaxy groups, and the Virgo supercluster being one.
It could be one. There's definitely, like you can see some of the structure here when you crank up the visible galaxies in Cartesial. Like there's definitely a tendril of high concentration of galaxies going through here. I want to check out these two here. Looks like they might be peculiar.
I need to get to focus my system again, because after I pulled out the filter, I don't have any stars to go after.
Did you? So you've taken the filter out?
Yeah, I want to look at that 891 too, and I pulled the filter out.
But there's no field stars.
So now it is all off.
Yeah. Maybe a nearby bright star just to get close focus, and then to go back to 891.
Yeah, I couldn't find anything that is sharp.
Is it just that hazy out, you think?
Yeah, it is that hazy. Anyways, let me go out. By the way, I tried to use that mini computer, the B-Link, and it was always crashing when I load up everything into it. So I'm using my full-fledged laptop outside. So
Huh.
I thinking I should get a nicer, smaller, like portable out. I can keep it outside, which doesn't consume too much power and so forth. Then
Yeah, I'm still using a B-Link X55. It seems to be working well for me. Although my tablet that I used to remote desktop in, I accidentally snapped the USB-C connector off inside, so that it no longer takes a charge, so it's completely dead, which stinks. So I need to get a new laptop for the field.
So you have the mini PC 8 GB 128. That's what I have.
Which one?
I finally the B-Link 8 GB memory, right?
Yep, it's 8 gigabytes with a J505005 processor. It's the X55. It's very similar to the one that you have.
Yeah, I have the J45 actually.
So I think that comes with the N4100 processor, which is very similar. I think the J5005 is only like maybe 10% faster. So
Yeah,
they're very, very close.
J4205 it says. J4205. Okay.
Oh, okay. Different. But should still be pretty comparable.
8 gigabytes. And it kept crashing, and I was desperately. I finally used it for I asked my local server to do some other things, but.
So when you operate it, say with a mouse and keyboard, is it stable, or is it only when you're going over network?
Yeah, I bought a small display. Another problem I felt was that when something has an issue, it was easier when it has working with a small mini PC without a
Headless,
screen.
no screen, no keyboard.
Yeah, so I thought so now I'm considering a laptop which I'll keep it closed, and that would serve the purpose. I'll just remote into it. I mean, in fact, that's what I'm doing now. I'm just remoting into my laptop.
I'm tempted to do the same, because the laptop I'm looking at is the AMD Ryzen 5 4000 series. They have a mobile low power versions, and they only draw like 15 watts, but they have 6 cores, hyperthreading to 12, and expandable memory up to 16 gigs, and I think they're like $500. So I was very seriously considering that one, but they're all sold out.
Yeah, I was looking for the Ryzen 2 because I heard Ryzen has one of the powerful computing, a laptop gaming that people are using it for.
I use in the 2 PCs that I recently built at home. In my desktops I have Ryzen's.
What was the model that you were thinking? Ryzen
I was looking at the Acer Inspire 5, and then there's a couple different choices for CPU, but it seemed like the most affordable, reasonably well specified laptop that came with the Ryzen 5.
Yeah, okay. Yeah, they look pretty nice. Razer.
And then like the Lenovo was comparable in price and feature.
I'd like to connect it to my I have an external battery also, which I use. I would like to, with this will come with I need to buy a separate one, I guess.
Yeah, I wish they would commonly disclose what voltage the charger is, because this one has a DC barrel jack charge. Because after that Huion or Chewy tablet, my Chewy tablet only charged through USB-C, and in my opinion, a USB-C is useless. It is not fit for field service. There's no retention, nothing to keep it in. It cannot be used for cameras because they just fall out and disconnect. And it's such a delicate connector. The center contact blade is paper thin. It's not very good. 2 out of 10. Do not recommend.
Was a USB wireless hub. All our devices are going into a USB. It doesn't have to necessarily go into a computer outside. So for about $150, you can get a USB wireless hub, and if you are about within 50 meters of that, you can connect it to your computer, so you don't have to invest into another computer.
That's pretty cool.
I don't know.
You just have to.
Work, but there are pros and cons to it.
Yeah, I think bandwidth and stability would be the first concern.
Yeah.
But if it works fine, then that'd be awesome. Oh wow, look at that teeny tiny Hadron galaxy there. Oh shoot, I never renamed these.
What is that galaxy you are just now looking at?
It's NGC 672. And I'm just going to adjust the view and get it a little closer to center. Oh, wrong way.
It is quite breezy here. It's very cloudy. Huh. Yeah, it is cloudy here. That explains it. Yeah, I got clouds. I can't do much.
Are they like really thin, high cirrus clouds?
I really don't see any stars for that matter.
Oh, geez.
Yeah, it is all clouded up out here at least. I think it is going to. Well, it will be a couple of days before the next clear sky happens.
Yeah. I'm interested to try more lunar. So if it's a clear sky with a decent moon, I want to try that 5x Barlow and do some lucky imaging. With the bigger cameras, the 533 included, you can just use a region of interest, and when you crop it down to smaller pixels, you can get much higher frame rates, which is pretty cool. So you can get like 200 or 300 frames per second at, you know, half a millisecond exposure and get a lot of data really quickly, and then run it through those magic programs. But still a lot to figure out there.
Someone is online with you still, huh? Who is it? Curtis is on.
In the comments, yeah.
Yeah.
Not sure if he's still there, but he is talking about the Dobsonian. He was mentioning how he'd never sell a 10-inch, and a 10-inch Dob really is the perfect size. Like anything bigger, and it's a little harder to move. But the 10-inch is so portable, it just fits. At least mine was a solid tube. Looks like his is a collapsible truss tube. but even the solid tube, it fit right in the back seat of a car, which is nice.
I just came out and I'm looking out, and I don't know whether this dust. I have my headlamps on, and obviously when you put your headlamps on, you can very clearly see the dust in front of it. I've never seen this much amount of dust. I'm not sure if this is because of that event from California that is bringing in these.
I hope not.
Because I can actually see this humongous amount of dust that is. It is serious amount of dust. I've never seen this much. It is like small, tiny particles, just like. I'm sure you will find it too if that is the case.
I'm gonna go out and check because I don't want my optics to be covered in that.
It is literally pouring dust.
Uh-oh.
Yeah, I've never seen this before. Anyways.
Looks like Curtis in the chat was saying that he has his 10-inch f5 Dob is solid tube, but a 12-inch f4 was converted into a truss tube. How is the 12-inch f4 visually? Do you use it with a Coma corrector when you do visual, or is it okay without one? Okay. Nice. So does the scope stuff have a motor kit, or is it on an equatorial platform? Oh, dang. Nice. How much does it weigh, the truss kit? It's not bad. Nice. The CGM is in the runnings. I think it could work for mine. Either a EQ6, a CGM, maybe an Atlas, or locally I know someone who has a Lost Mandy G11 in a barn, and I've got a reasonable price on it as a backup in case my motorized Dob doesn't work out. Nice. There's in the Onstep'ed project, it's a pretty technical endeavor to take it on because a lot of the mechanical solution is up to the user, but they have support for field derotators, but you'd have to construct it yourself, which could be pretty challenging to make precise enough. But it'd be pretty slick to have an alt-az with a derotator. Oh wow, there are 2 edge-ons right there. Teeny tiny distant ones. Nice. Oh yeah, I bet you would need a 3-inch focuser for the full frame A7. Did you need to get a bigger secondary? Good point. I think with the I've got a Bresser 208mm f3.9. I forget the model number, but it's very similar to the Explore Scientific imaging newts. And with the micro 4/3, I think I only lose maybe 17 to 20% brightness in the corners. So with the flat frame, it perfectly recovers. It's nice. But you're right, most of the time is spent here in the middle, so it doesn't really matter too much. It's the other thing I've been wondering how I'll do is how to make the flat fields for the 12-inch. I'm gonna have to build some sort of custom light box. They make tracing tablets. Right now I have an A3 tracing tablet, which is oversized for the 8-inch, but that's good because it makes it a little more uniform. And I think they make them even bigger, big enough for the 12-inch, but they get pretty heavy because they're a solid sheet of acrylic. So, oh, looks like I'm going over the meridian. So I've been thinking about ways to make some sort of fabric tent-like construction. How do you like Astrotoaster, or how does it compare to SharpCap so far? I've got a member in our club who's interested in doing EAA, and he has a nice Sony DSLR. So I've been thinking about recommending Astrotoaster to him. Is your DSLR unmodified? Because with the ZWO camera, recently I started using a UV-IR filter, and I found that really helped the colors become more natural. So I wonder if it's just the internal filter in the DSLR, or is it the Astro Toaster? Tonight I'm not using the UV-IR just because there's so much smoke. I want to make use of that limited IR light that's making it through. Oh, okay. So it is Astro modified. Must be really nice using the full frame sensor though. Even moving from the 1/3 inch 224 to this 3/3 inch or 3 micro 4/3 294. It's been really nice to be able to kind of surf around the field of view. I can't imagine how massive and wide a full frame would feel compared to it. The 224 is incredible in what it can do. It's a small sensor, but the less than 1 electron read noise lets it get away with incredibly short exposures. Until recently, it was completely untouched as far as shortest exposure possible. I think the new 462 camera might be slightly faster, but it's a lot more expensive, and it's still a tiny sensor. Oh, it looks like that has a dust lane going through.
about that.
Yeah, no problem. I just wanted to make sure you were aware of it. Yeah.
This is the time I get to call the other side of the globe.
Yeah. Oh, I hadn't heard of the 482. I'll have to look into it. Sounds promising. I wish they made a mono version of one of their newest gen chips. I'm still excited for the IMX 492, or the mono equivalent of the 294, but the 294 isn't perfect. I'd be really excited if they made a mono sort of APS-C or Micro Four Thirds mono version of their newest gen chips. That'd be awesome. Because I used to use the 224 in a smaller 4.5-inch Newtonian, and I also had a 290 mono, and it was a lot of fun. It was like gaining a 3x speed boost for free at the cost of color. So maybe not for free, but for galaxies it was worth it because they're essentially monochrome anyway. The number of background galaxies here is insane. With the expanded Deep Sky Scat catalogs installed into Carte to Seal, it'll actually end up showing most of them, which is pretty cool. Looks like this one has some faint wings coming off, maybe like this and that. I think I might wrap it up after this one. Just looking at the California Nebula. I think I'm gonna end it. Thanks for tuning in. Have a good one and clear skies.